Hello everyone. Um, I'm not sure if you can hear my sound now. Is my sound clear to you? If you can hear me, just respond in the chat box. um, Hello, can you hear me? Okay, perfect, perfect. Thank you. Sorry for the delay because this is my first time to run on the live stream. But anyways, let's get started. Just before we start, let me confirm that this session is just for you. So if you have any question anytime, don't hesitate to send your question in the chat box. Sometimes there is a kind of delay, but I'll come to your question for sure. Until we have more of you here, let me go quickly through a revision of the main points of organic chemistry. So I'd like actually to start with the reaction scheme of organic chemistry. This is a reaction scheme for organic chemistry. By the way, you know that this live is going to be there all the time on the YouTube, but from time to time you may want to take a screenshot from what I'm showing to you, or if you feel like anything is not clear, just send me your question. But I will try just to touch on the main points and questions that I may expect to show up in the exam. So as you may see here, that map or scheme connects everything you have in organic chemistry, starting from the very left of that scheme, from alkanes. You know that alkanes, they are less reactive than alkenes, but they can make a kind of reaction known as combustion and substitution. If you are cracking longer chain alkanes, they are going to give you alkenes. Okay, so you may start with longer chain alkanes and then move to alkenes through a process known as cracking. Once you have alkenes, the type of reaction that you may proceed or you may go with alkenes is known to be addition reactions. And in addition reaction, you may add bromine, you may add hydrogen, you may add steam, and finally you may make a process known as polymerization. And we'll go through everything in detail now, but I'm just giving you the general idea. So one of the reactions, it takes you from alkenes to alcohols, and that reaction by adding steam. So you may move from alkenes into alcohols, and we have another route to get into alcohols, and that by fermentation of glucose or sugar. Okay. And once you have alcohols, then you can make a combustion. Once again, any combustion of any organic compound, it always gives you carbon dioxide and water. Oxidation of alcohols gives you carboxylic acid, which is the fourth homologous series we have in organic chemistry. Or you may make an ester from alcohols with a process or reaction known as condensation. Okay, this is a kind of like a general map, but I'm going to get into some detail. Of course, I'm not going to explain everything, but at least I'm just going to touch base on some of the points here. Let me get to like point by point. So I'm going to start with the displayed formulae. Before, in older versions of your exams, he used to tell you that draw the structure and show all bonds of an organic compound. But I think in recent versions of the exam, he would ask you to draw what's known as displayed formula. So if he asks for displayed formula, it means you have to show every bond between atoms. Okay, and here, as you may see, we have four homologous series. Those are the homologous series we have. When I say homologous series, by the way, it means families. So here we have four families of organic compounds. We have alkanes, we have alkenes, alcohols, and we have carboxylic acids. And the fifth and last family is esters, and esters are mainly a reaction between alcohols and carboxylic acids. So as you may also see, we have four members of each of these or four carbon atoms in each of these homologous series. The displayed formula always shows the bonds between atoms. When you write the total number of atoms and you show it in as a total, that's said to be molecular formula. Okay, and then we have some definitions. We have, as you may see here, we have almost like 5 or 6 definitions, but this year I expect one of these definitions to come in the exam: homologous series or structural isomers. I think one of them would come in the exam. Homologous series, as you may see here, the definition, it's a kind of like repetition of the information here, but you see that we have 3 common characteristics. I mean, they are same in 3 of the characteristics, and they are different in 2 characteristics. So a homologous series, they are compounds that have the same functional group, the same general formula, and the same chemical properties. So they are same in functional group, general formula, and chemical properties. And by the way, the reason for having the same chemical properties is because of having the same functional group. And it came before in one of the exams. He asked why those 2 compounds that are of the same homologous series, why they display or why they have the same chemical properties, and the answer is because they have the same functional group. Like, let's say we have 2 alkenes, both of them would make addition reactions. If you have, let's say, 2 alcohols, both of them can make condensation reaction. So of the same homologous series, you'd have the same chemical properties or chemical reactions. However, they have different physical properties, but the physical properties, they are differing in what's known as a trend. A trend means in a gradual and predictable way. Okay, and also they are different from one another by a CH2 unit. Let's say we have the homologous series of alkane. The first member is methane, CH4, and the second member is ethane, C2, H6, and so on. We have propane, C3, H8, and so on. So from one member to the next member, the difference is CH2 unit. Like the difference between CH2, C2H6 and the previous member CH4, the difference here is CH2 unit. And the difference from ethane to propane, the difference is also CH2 unit. Like you can add CH2 unit and you move to the next member. So consecutive members are different, or they differ by CH2 unit. So once again, in the exam, if he asks you to define a homologous series, you may write 2 of these similarities among them, or you may just mention all of them if you have time for mentioning all of them. Okay, so once again, they have the same functional group, they have the same general formula, and they have the same chemical properties. However, they are different in physical properties, and they are different by a CH2 unit from one member to the next. Okay, this definition is extremely important, and maybe it's going to show up in the exam. The next important definition is structural isomers. So structural isomers, mainly when this definition comes in the exam, it comes with 2 marks. 1 mark for mentioning what is the similarity between structural isomers, and they are similar in molecular formula, and how they are different. They are different in a structural formula. Structural formula, it means they are different in arrangement of atoms. Here we have an example. Like if you have C4H10, that's the molecular formula. It may be showed in 2 ways. The first way is a straight chain without any branches, and the second way you have here a branch. You know that you have a branch if you have a bracket. It means it's a branch. I mean, it's above or below that middle carbon. I may just show it this way. Like here you have the 3 carbons in one chain, and then you have a third carbon as a branch. Of course, each carbon should have complete 4 bonds around them. So you should have here 3 hydrogens, and there you should have 1 hydrogen, and down below you have 3 more hydrogens. And there also you have 3 more hydrogens. Okay, that's a displayed formula of what you see here on the left. I hope that's clear. Okay, so one of the two definitions will show up in the exam, I hope. Homologous series, we have 5 characteristics, 3 similar characteristics, and 2 different characteristics. But in structural isomers, they are the same in molecular formula. I mean, they have the total number of atoms, but they are different in their arrangement. You may have here, as you may see here, you have a branch here in the middle, and you may have them, all of them, as a straight chain in one line, okay, which is the first structure you have on the left. Okay. Um, okay. As I mentioned, we have 5 homologous series. We have alkanes, we have alkenes, and we have alcohols. And okay. Yeah, that's what I'm doing, Juman. I will just go through naming now, which is the point that is just coming after the explanation of structural isomers. So as I mentioned, we have 5 series. We have alkanes, alkenes, and we have alcohols, and we have carboxylic acids. If you react alcohols to carboxylic acids, they give you esters. So we have a total of 5 families. The name of any organic compound should have a beginning and an ending. Okay, so any name should be a beginning and ending. The beginning tells you how many carbon atoms you have. Okay, so once again, the name of any organic compound should be a beginning, a part that has to be on the left side. That's beginning of the name, and an ending of the name. That's what you have on the right side. The beginning always how many carbons you have. Let's say you have a compound with 1 carbon atom, then you have to put meth at the very beginning of that compound, whatsoever the family is, whatsoever the homologous series is. Okay, in any of these 5 homologous series, if you have 1 carbon atom, it should always start with meth. If it's 2 carbon atoms, it should always start with F. Okay, so 2 means F, 3 means prop, and 4 means but. Of course, we have more than but, but for your syllabus, just you are limited to but. Okay, so once again, the name of any organic compound should be beginning and ending. Beginning tells you how many carbon atoms you have, and we are limited to 4 carbon atoms. If it's 1 meth, 2 eth, 3 prop, and 4 but. Now, what about the ending? The ending, you take it from the family. So as you see, we have, let's focus on the first 4 families. So once again, we have 4 families. We have alkanes, alkenes, alcohols, and carboxylic acids. I'm just going to focus on these 4 because you know the fifth esters, which is the most challenging among them. It's just a combination between alcohols and carboxylic acids. So if it's an alkane, then the ending has to be ane, which is the last 3 letters from the family ane, A-N-E. If it's an alkene, then it has to end with ene. If it's an alcohol, then it has to end with ol. If it's a carboxylic acid, it has to end with oic acid. Okay, so we have a beginning and an ending. So let me just repeat here on the right side. I'm just going to repeat once again. The name of any organic compound should be a beginning. I mean, a first part. Sometimes we call it a prefix. Okay, so it's a beginning, and we should have an ending. Now, the beginning can be one of these 4 beginnings. It could be meth if you have 1 carbon atom in the structure. It could be eth if you have 2 carbon atoms. It could be prop if you have 3, or it could be but if it's 4. The ending depends on the family. If you have an alkane, I mean, if all carbons are singly bonded, then it's ane. If you have an alkene, then the ending is ene. If you have an alcohol, then the ending is ol. If you have a carboxylic acid, the ending is oic acid. Now you can make any combination. Like let's say that you have carboxylic acid with 1 carbon atom, then it's going to be methanoic acid. Let's say that you have 2 carbon atoms, but they contain the OH, I mean, they are alcohols, so it's going to be ethanol. Okay, of course, here in any of them, if it's an alcohol, then we add also into it, so it's going to be ethanol. If you have 3 carbon atoms, but it's an alkane, it's going to be propane. let's say you have 4 carbon atoms, but it's an alkene, it's going to be butene. By the way, here for alkenes with 4 carbon atoms, you have to tell me exactly where is the double bond. So it could be a but1-ene or but2-ene. We'll come to this part later. Okay. Um, yeah, sure, sure. I'm going to do some past paper questions, but I'm just waiting. Oh, um, okay. I think now we're here. I'm not sure if this number is a kind of like glitch in the YouTube, because I was expecting to have like I'm not sure. Okay, now we are 1,000. Oh, how come? Anyways, so I will do some past paper questions. I was just waiting for some of you to come to the live stream, but anyways, I'm going to do the past paper questions. Okay, now, okay, just quickly, I'll try just to touch base on some points very quickly. For fuels, the most important point here, a definition of a hydrocarbon, as the name implies, compounds with just carbon and hydrogen. So if you got a question why this compound is a hydrocarbon, because it contains only hydrogen and carbon. And here we have the fractionating column. We use it to separate different fractions of petroleum, and it's a common question to pick any of the fractions at the bottom. Like, let's say he's going to pick, let's say, the fuel oil fraction, and one of the fractions on the top, let's say he would pick gasoline fraction, and tell you how they are different. Then you have to pick any of these properties. As you may see here, as you move from the bottom up, then we are getting lower in 3 of the properties. We are getting lower in the chain length. I mean, the chain length is going to decrease, viscosity is going to decrease, boiling points are going to decrease. However, volatility is going to increase. So a fraction on the top is going to be lower or less in the chain length, and also it's going to be lower in viscosity, boiling point. However, it's going to be higher in volatility. And here you have the fractions, and you have a mnemonic device just in case you need to memorize those fractions. However, I don't expect him to ask you about like the order of these fractions, but here you have a mnemonic device: rise greatly now, keep driving forward like a boss. Rise, so here you have the R for refinery gas, greatly for gasoline, N for naphtha, and so on. But you have to know the uses of them. As you see, 4 of them, they are used as fuel, but you have to know which type of fuel you have. Like gasoline is a fuel in cars, kerosene is fuel in jets, and diesel is a fuel in diesel engines, and fuel oil is fuel for ships and heating systems. Okay, bitumen is a fraction. It's a fraction that's used in making roads. Okay, so uses are important. Just know them, and I don't think you have to memorize the order of them, but you have to know which one comes on the top and which one comes on the bottom, just in case he's asking you which one is higher in volatility, which one is more volatile, and which one is less volatile. Okay, okay. Um, Alkenes are singly bonded. I mean, the carbon atoms are singly bonded, and they are saturated, and they are unreactive. They are less reactive, except for their combustion and substitution. By the way, when he gives you a reaction of an alkane and asks you about the type of reaction, you have to mention both of them to be in the safe side. Like, let's say he gave you methane and chlorine and ask you what type of reaction is it, you have to say both it's a substitution, and at the same time you have to mention that it's a photochemical reaction, because you don't know which keyword he's interested in. But if he mentioned one of them, like let's say he told you that reaction of methane with chlorine is a photochemical reaction, and then he asked you in one of the parts, what type of reaction is it? He already told you it's a photochemical reaction. Then you have to tell me the other term, which is substitution. But if I didn't mention any of them, then you have to tell both it's a substitution reaction and it's a photochemical reaction. Photochemical because it depends on light. It needs an ultraviolet light to provide the activation energy. It means this reaction wouldn't happen unless you have light or ultraviolet light to overcome or to activate reactants to make the products or to proceed with the reaction. In the syllabus, we are just interested in mono-substituted. I mean, we are removing one of the hydrogens and we are replacing it with a halogen like chlorine. However, you may have di-substituted. You may expect him to give you another step. Like after forming mono-substituted, you can go again through the process of substitution and you can make again another substitution reaction, and then you can remove another hydrogen atom. Like you may have di-substituted, like in this example here, I may have carbon and two chlorine atoms because I run the reaction 2 times. Now it's di-substituted, but mainly in the exam he would ask you, I expect to be just a mono-substituted question. Next, alkenes, they are doubly bonded and they are unsaturated and they are more reactive than alkenes. The manufacture of alkenes through catalytic cracking, we need high temperature, and then we crack that alkene into alkanes and alkenes. Okay, and that's intuitive, guys, because you cannot have, like, let's say that you want to split that compound into two halves. The hydrogens are always even numbers, so if you split it evenly, it will be two odd numbers, and that couldn't happen in inorganic compound to have odd numbers of alkenes or alkenes. Okay, so you should have one of the reactants. It should be an alkane, like that first one, and one of them should be an alkene. But the splitting or the fraction, I mean the splitting between the carbon chain, it doesn't have to be even. Like it doesn't have to be 6 carbons in that example. It could be like 2 carbons in the alkene part and 10 carbons in the alkane part. Even you can split it into more than like 2 parts. Okay. So you can't expect exactly what alkene and what alkane you'd have. That's why he has to give you a clue in the question. Like he would tell you that cracking of that alkane, let's say that we have a decane. Decane means you have 10 carbon atoms. So 10 carbon atoms, and we need, according to the general formula, we need 2n plus 2. So we need here 22. Okay. You cannot tell how cracking will give you the product. It can be like 5 carbons in the alkene, 5 carbons in the alkane. I mean, they are split evenly. Or you could have 4 in the alkane part and 6 in the alkene part. You can't tell exactly. That's why he has to tell you that one of the products, it's 2 carbon atoms alkene. So it's C2. If it's an alkene, it will be H4. And the other part, of course, is the alkane part. That's why you should have C8 H. When you multiply 8 times 2, it will be 16 plus 2, it will be 18. So overall, you have 22 hydrogens and you have 10 carbons. Okay. No, cracking, Muhammad, it happens just for alkenes. We cannot crack alkenes. Okay. Alkenes are the products of cracking of alkanes. And alkanes have to be, by the way, longer chain. I mean, you cannot crack an alkane that's already like 2 carbon atoms. It has to be long chain alkane. It has to be an alkane like decane, 10 carbon atoms. It has to be even nonane, something that's more than generally more than 2 or 3 carbon atoms. Okay. Next. This part is new and it's not common in the exams. However, you may expect it to be in the exam. Like, why do we crack larger alkanes? Because shorter alkanes, even shorter alkenes, they are in greater demand, and to match the demand, we need to crack them. So we crack alkanes to get alkenes and match the demand of having shorter chain alkenes. Okay. Addition of alkenes. Now, this part is important, guys, and he may leave everything but just ask you about conditions. So you have to be aware of conditions. As I mentioned before, you may add bromine, you may add hydrogen, you may add steam. Okay. Now, adding bromine, it happens at normal conditions. I mean, at room temperature. You don't need any kind of like extensive conditions. However, adding hydrogen and adding steam, you need special conditions. If you want to add hydrogen, then you need a catalyst, and mainly it's a nickel catalyst, and also you need high temperature. So conditions here are catalyst and high temperature. And guys, also I want to emphasize that there is a difference between reagent and condition. Okay, if you ask for a reagent, it means let's say we have an ethene, which is an alkene. You may have any alkene, by the way, but in this example we have ethene. I mean, 2 carbon atoms. The reagent here is hydrogen. I mean, hydrogen is going to get involved into the reaction and is going to form the product. However, conditions are high temperature and catalyst or nickel catalyst. Okay, so in the exam, if he asks for reagent, it means the reactant that comes with the main reactant. Like here, the main reactant is ethene and the reagent is hydrogen. But if he asked for conditions, now conditions are catalyst or nickel catalyst. Or by the way, you may have many other transition elements catalysts. And also we need high temperature. Okay, so those are the conditions, and the reagent is just hydrogen with the alkene. Okay, now if you want to add steam, then you have one more condition. You have to also put the reaction under high pressure. So here we have 3 conditions. We have to use a catalyst, and the catalyst, by the way, is an acid catalyst. In the old syllabus, they used to tell you that that acid catalyst is phosphoric acid, H3PO4, but in the new syllabus, you don't have to memorize it. Just say acid catalyst. So that's one of the conditions. And the second, you have to memorize these numbers, guys, by the way. The second condition is high temperature, 300 degrees Celsius. Adding steam to an alkene, you need high temperature, 300 degrees Celsius. You need high pressure, 60 atm, or you may use kilopascal. If you want to convert between atm to kilopascal, then you have to multiply by 100. It means 6,000 kilopascals. So first you need a catalyst, an acid catalyst. You need high temperature, 300 degrees Celsius. You need high pressure. Those are known to be conditions. The reagent is steam. Okay, good. The first addition reaction, which was with bromine or bromine solution, is also used as a test to distinguish between saturated and unsaturated, alkanes and alkenes, saturated alkanes, unsaturated alkenes. If the color makes a change, I mean, if it decolorizes, then it's an alkene. If you have no change, it's an alkene. If you have a color change, you have just to tell him that the color went from orange or brown into colorless. The verb is to decolorize, or you may say the bromine solution decolorizes. And if it's an alkane, since we don't have any double bonds, it would stay as brown or orange, so you have no color change. Okay, guys? So an alkane undergoes no color change. And if he asks you why, because we don't have any double bonds. In other words, there is no reaction that would happen. So the bromine would stay as it was before, brown as it was originally, without any change. But here, since bromine was involved in the reaction and there is a reaction that takes place using that bromine, so you have, of course, an addition reaction. So that's why it decolorizes. Okay. Perfect. Sorry guys for taking like a long time in that, but I think it would save a lot of time when you go through questions, because we're just going to answer questions directly without having to explain any of these points. Okay, thank you, Juman. Thank you, Muhammad Tawheed. um Muhammad, does the reaction of bromine with alkene. Yes, Muhammad. When the reaction between an alkene and bromine, when it takes place, it forms alkane. Okay, no more alkenes. All alkenes will disappear, and then they will form alkanes. So, in other words, they will turn from double into single bonds, and they will be like all of them will be saturated. So, no more alkenes. Okay, thank you. Now, let's move to alcohols. So now we finish with alkanes and alkenes, and now we're discussing alcohols. We have two ways to get into alcohols. Let me get back to that scheme here, over here. As we said before, you can get into alcohols whether from alkenes. So let me change color here. So here you have alkenes, and then you make an addition reaction with steam. Remember the conditions that you should put, or you should apply here on this reaction. You should have high temperature, 300 degrees Celsius, high pressure, 60 atm, and an acid catalyst. That gives you an alcohol. Another way to get into alcohols through the sugar, glucose, with fermentation. Now, this method, guys, it's much cheaper because all what you need, you don't need any kind of extensive conditions. You just need a temperature from 25 to 35 degrees Celsius. I mean, that's room temperature. You don't have to heat at all. So you're going to save a lot of energy here. Also, you don't have to apply any pressure. You just have to make that reaction in the presence of a catalyst known as yeast, which is a biological catalyst, yeast. Okay, and also you have to make sure that that reaction runs in absence of oxygen. We call it in biology, we call it anaerobic respiration or anaerobic reaction. I mean, you have to keep oxygen away from it. So the reaction has to be in absence of oxygen. Okay. So once again, we have two routes, two ways to get into alcohols through addition of alkenes with steam or fermentation of glucose. Okay, commonly in the exam, he would ask you about advantages and disadvantages. As I mentioned before, if you are using fermentation, then it will save a lot of energy because you don't have to apply any heat or apply any pressure. So no energy, I mean no heat or no pressure you need to apply. Also, the sugar itself is renewable. So that helps sustainability because you can get sugar all the time. It's not a kind of source that will end at all. So it's a kind of renewable source. Okay, so the materials are available all the time. So lower energy, lower pressure, and renewable, sustainable source of reactant, which is the sugar or glucose. However, that process of fermentation is slower. So that's a slow process. It takes time. And in industry, we're looking for a process that gives a yield in a shorter period of time. Also, however, it's not in the new syllabus. You may mention that it's not a continuous process, but it's not in the new syllabus. You just ignore the idea of continuous process. Continuous process, by the way, means you always supply reactants and gives you products all the time. You don't have to start. Sorry, continuous means you don't have to start a new batch. Okay, like a batch when you make a product, and then to get that product once again, you have to remove everything from the previous process, and then you have to start over from again. Okay, that's a continuous process. Continuous process means you don't have to start over, you just have to supply the reactants and they will give you the products. But a batch process means when you finish, you have to clean everything and remove everything and then start from scratch once again. So that's a kind of like a slow process. So you don't have to get into the idea of batch process and continuous process. Just say that it's a slow process. So fermentation is a slow process. But hydration of ethene or reaction of ethene with steam, it's much faster. However, it's energy consuming, but it's much faster. Okay. Yeah, yeah. Thank you, Juman. Also here, guys, you may notice that fermentation also it produces carbon dioxide, which also contributes to the disadvantages. Okay, so yes, it contributes to the idea of environment. So it's not like a process that is environment friendly. So yes, thank you, Juman, for mentioning that. Yeah, thank you. Um, So as I mentioned, in a reaction of ethene with steam, you need special conditions. You need high temperature, high pressure. So it's an energy consuming process. Also, you require ethene, and the source of ethene is mainly from fossil fuel. fossil fuel. Okay, so fossil fuel is non-renewable source. Okay, so the source here for hydration of ethene, hydration means reaction of with water or steam, because steam is a form of water. So that reaction, to get the raw materials, I mean to get ethene, you have to get it from the fossil fuel, which is non-renewable source. Also, you have to apply high pressure and high temperature. And also you may notice here, guys, that the first reaction, fermentation, it's one way. It means it finishes. It just takes some time. Yes, it's a slow process. It takes long time. But once you get that yield, the reaction is over. But here, the reaction down below, it's two ways. I mean, it's a reversible reaction, meaning you're going to get lower yield. It's a faster process, but you're going to get lower yield. I mean, not every reactant you have, not every single molecule of ethene, let's say, will get into ethanol. Okay, so it's a kind of reversible reaction. By the way, he wouldn't ask you for all of these advantages and disadvantages, just he would ask you to mention one or two maximum of these advantages. I just discussed all of them. Once you forgot any of them, you have the possibility of adding any other advantage or disadvantage. So once again, fermentation, it doesn't consume energy, or it doesn't require pressure, and it uses sugar, which is a renewable source. However, the disadvantages is disadvantages are, it's a slow process. Also, it produces carbon dioxide, which is a greenhouse gas, as Juman just mentioned. Okay, let's move to the next. Now, combustion of ethanol is exactly as combustion of alkanes. Just you have to produce carbon dioxide and gas, and make sure that you balance the equation. We'll come to balancing when we answer some past paper questions. But uses of ethanol or alcohols in general, they are used whether as solvents or fuels. You don't have to get into specific details, like why they are good solvents, because of their volatilities and all of these stuff. Just know that ethanol is used as a solvent or as a fuel. We add it to the fuel. It improves the properties of fuel, but you don't have to explain why. You just have to know that it's used as a solvent or as a fuel. Carboxylic acids, we're almost done. Just bear with me, just a few minutes. So carboxylic acids, so they are just acids. They make the normal reactions of acids, like they can react with metals to produce a salt and hydrogen gas. They can react with bases to produce salt and water, neutralization reaction. They can react with carbonates to produce the salt, carbon dioxide, and water. So normal reactions of acids. Now, this part is important. How to get carboxylic acids? We make oxidation of alcohols, and then we get carboxylic acid. The main reagent is acidified aqueous potassium manganate. It comes a lot in the exam. I would ask you, how would you make the carboxylic acid, like ethanoic acid, from ethanol? You have to make oxidation, and the reagent that's used to make that oxidation is aqueous potassium manganate. It has to be acidified. Also, you have to apply some heat, just in case he asks for more than one condition, acidified and heat. That's not common in the exam. However, it may show up in the exam. Also, one way of oxidation is a kind of like more biological oxidation of alcohols. It's called bacterial oxidation. So we use bacteria. That bacteria act as like a catalyst. They can change alcohols into the carboxylic acid. Okay. Okay. Now, the reaction between a carboxylic acid and an alcohol, that reaction produces the last family or homologous series, which is esters. Okay, the conditions here are having a catalyst, acid catalyst. Also, you should have an acid catalyst for this reaction to be done. By the way, guys, I forgot just to mention that the general formulae that you need to memorize are 4 general formulae. Let me get back here to the very beginning of that revision. Okay, here. Yeah. You have to memorize the general formula of an alkane, CnH2n, alkene, alcohol, and carboxylic acid. Now, the general formula for esters, you don't have to memorize. Normally, it will be given to you in the exam. Like in the exam, he would tell you the general formula of esters, CN, H2NO2. But you don't have to memorize this. But you have to know alkane, alkene, alcohols, and carboxylic acids. Okay. Now, that part, almost like 100% in all the exams, it has to show up. How to name an ester. As I mentioned before, ester comes from an alcohol, a parent alcohol, and a parent carboxylic acid. Carboxylic acid has to always come, in naming the ester, has to always be at the end. Okay, that the carboxylic acid root has to be at the end, and the alcohol root has to be in the very beginning. Like, let's say that you have an alcohol of propanol, and you have a carboxylic acid, let's say, of ethanoic acid. So once again, remember, eth means two carbons. So we have two carbons. There are two carbons, and those two carbons are making an acid, carboxylic acid. Carboxylic acid means, if I want to show the displayed formula, you have an oxygen here, and you have oxygen and hydrogen there, and here you have hydrogens everywhere around this left-hand carbon. So that's a carboxylic acid. Since we have two carbons, it's eth, and it's a carboxylic acid, so I have to add oic acid. So ethane, it has also to contain the ane part of the alkane, and oic acid, ethanoic acid. Let's say this is a parent carboxylic acid of an ester, and let's say you have the parent alcohol. Let's say we have three carbons that are making the parent alcohol. So here we have three carbons. Okay, and also let's consider that the carbon at the edge here, it carries the OH. Now the other carbons should just be or carrying just hydrogens, or bonded to hydrogens. Okay. Now, if you want to combine both of them, by the way, the name, I forgot to tell you that this is prop, because there are three carbons, and also you have to add the ane part of an alkane, because they are singly bonded here, the carbons are singly bonded, and you have to add ol, so that's propanol. Ol because you have an alcohol functional group, and ane because they are singly bonded, carbons are singly bonded, and prop because they are three carbons. Now, if you want to mix between them, and not mix, sorry, I should say react. If you want to make a reaction between them and get an ester, then you have first to start with the alcohol part, and then you have to put the acid part at the end. And the name should be, you should take the root of that alcohol, so it should be prop and then YL. Okay, so the ester should be the root, how many carbons you have, and then add YL to it. And that comes from the alcohol, as you may see here. And then the acid part will be, here you have two carbons, F, and then ane weight. So the final name will be propyl ethanoate. Okay, so a weight, that's from the acid part, and propyl, that's from the alcohol part. Let's say you have more alcohols and more carboxylic acids. Let's say that you have an alcohol with two carbon atoms. Two carbon atoms means you have eth, so it has to be ethyl. Remember that the alcohol part always ends with YL, so that's ethyl. And the carboxylic acid part also, it has two carbons, so that's ethanoate, so ethyl ethanoate. Let's say the alcohol has three carbon atoms, it's going to be propyl, and the acid part may have just one carbon, that's meth, and then you add anoate to it, so methanoate, so propyl methanoate. And finally here you have an example of methyl butanoate. You have to practice this point, I mean, how to write the name of an ester, because it shows up in the exam always. I mean, like, I can't remember that I found any exam without asking for a name of an ester. Okay. Um, yeah, sure, Muhammad. Okay, first I'll come. Okay, let me take the question of Muhammad first. Uh, Yes, of course, cost is important, Muhammad. If you mean disadvantages, yes, cost is important. Of course, if you need high energy, it means that's a costly process. We need that's more expensive process. Yeah, thank you. Okay, so let me get back to the butene. Okay, butene. Okay. Um, Guys, you may remember when I explained structural isomers, I told you that the functional or the structure of the compound may change. However, you may have the same molecular formula. Molecular formula means the total number of carbon and hydrogen atoms, let's say here in but 1-ene and 2-ene. So here we have 4 carbon atoms in these two examples. So here, just let me put here a circle around the but 1-ene and but 2-ene. Okay. In both of them, you have 4 carbon atoms. If you count carbon atoms, you have 4 carbon atoms. And in both of them, you have 8 hydrogens. So both of them, they are sharing the same molecular formula. They have the same total number of carbons and total number of hydrogens. However, on but 1-ene, the double bond is between carbon 1 and 2. Of course, double bond has to be between 2 carbons. We just assign it to the least carbon, I mean to the first carbon. So it's but 1-ene because it's on carbon number 1, the first carbon here from the right side. And the other one is but 2-ene. If you start from the right or left side, it's the carbon in the middle, I mean the second carbon. Okay, so there's a difference between but 1-ene and but 2-ene, and both of them, they are structural isomers, meaning they have different structures, different arrangement, but they are sharing the same molecular formula. Um, um, Muhammad Siraj, if one then function group is on first carbon. Yeah, I think you mean, Muhammad, for if it's a carboxylic acid. Did I understand your question correctly? So I think Muhammad Siraj, he just wanted to refer to carboxylic acid. So what if a carboxylic acid has just one carbon? Like if it's just one carbon, yes, Muhammad, the function group will be just that carbon. Okay, because the function group is part of, I mean, you don't have any other carbon. So yes, it's one carbon, and that one carbon is at the same time the function group. So that's the smallest carboxylic acid you have. So it's meth because it's one carbon, and then ane, methane, and then of course you have to add oic acid, methanoic acid. That's a carboxylic acid. Okay. Um, yeah, and also you may notice here, okay, let me get back to that table once again. Okay, guys, also you may notice here that the first member of an alkane is methane. You may have one carbon that's making an alkane, but the first member of an alkene, it should be with 2 carbons. So the first member of an alkene, it's always like start, I mean, you couldn't start from 1 carbon an alkene. You should have at least 2 carbons. So N should be 2 or more. The first member of alcohols, it could be 1 carbon. You can start with 1 carbon, and the same for carboxylic acid. So as Muhammad just mentioned here in the methanoic acid, N is 0. Yeah, you may have N is 0. I mean, you just have the function group, and at the same time, it's the carbon, the only carbon you have in the compound. If 2, I didn't get that, Muhammad, correctly. So if 2, then function group is on second carbon. Um, you mean if you have 2 carbons, is it? Just you may tell me more about your question, Muhammad. I didn't get your question. Okay, Muhammad Siraj. Okay, um, we're almost done. Now, polymerization. Here you have the general classification of polymerization when you make a longer molecule from smaller molecules known as monomers. You can do it through addition or condensation. In condensation, you could have polyamide or polyester. Polyamide, you may have a natural polyamide, natural proteins, or you may have synthetic polyamides. And synthetic polyamides, if you remember, guys, um, was answering. Ah, thank you, Muhammad. Thank you. Okay. Or you may have synthetic polymers or polyamides, I mean. Okay. Nylon. Okay, polyesters, PET. And by the way, guys, in the old syllabus, he used to use terylene, and terylene is not anymore in the exam. But however, terylene and PET, they are almost the same. There is a slight difference between them in the applications, but you can consider it as PET. So in the new version, I mean the new syllabus is PET, and you don't have to know what does PET stand for. You just have to know that it's a polyester. That's it. But you don't have to know the exact name of it. Okay. Since I think, how long is it now? I think we're approaching the first hour. Okay, so let me quickly get into the tricky points here. Yeah, the main point that some of you are doing it wrongly is the when he asked for a monomer and when he asks for a repeat unit or repeating unit. If he asks for a monomer, and it's an addition polymer, then you have to show the double bond, because monomer means before making polymerization. But if he asks for the repeat unit, it means now when it's part of the polymer itself. In other words, you have to show the extended bonds. You have to make the bonds open, and you have to remove the double bond. We're going to apply on many examples now. Don't worry if you didn't get the idea, but there is a difference between monomer and repeat unit. Remember, monomers are smaller molecules that when combined together, they give you the polymer. Okay, let me give you an example because I think some of you may get lost with this part. Okay, so let's look at this large molecule here. It's a polymer, okay? By the way, it's polyethylene because that large molecule, it came from smaller molecules. They are separate now. Before making a reaction, they are separate. So each of these smaller molecules, they are said to be monomers. So each one is a monomer. Okay, if he asks for a monomer, then you have to show the double bond. This is an addition polymer, by the way, because addition polymers, they happen in case you have a double bond or an alkene. So here you have smaller monomers and they contain a double bond. That's why they are making addition reaction. But if he asks for a repeat unit, all what you have to do, you have to take any two carbons in that structure of a polymer and put a bracket around it. Any two carbons, and then you put a bracket around it, and then, sorry, and then just pull it out of the polymer. Okay, so that's going to be the repeat unit. The repeat unit here, just take the two carbons here, and you have up and down hydrogens everywhere around them, hydrogens, hydrogens. And then you have to keep the bonds open. Now it's a repeat unit. A repeat unit. So what's the difference between a monomer and a repeat unit? A monomer is a molecule, a small molecule before reaction, and it contains a double bond. A repeat unit, now after reaction, you take a unit that when it's repeated, it gives you that polymer. I mean, you take just part of that polymer already formed in the equation. If you got that large molecule here, that's a polymer. How would you get the repeat unit? Pick any consecutive, any carbons that are just beside each other. Okay, just pick any carbons, any two carbons. Okay, any two carbons, and then put a bracket around them and put them out of the molecule, and that would give you the repeat unit. Let's say that I'm going to pick that carbon and this carbon, any two consecutive carbons, and then put a bracket around them. That's going to be a repeat unit. Just take it out of the molecule. So here it's going to be, those are the two carbons that I picked, hydrogen up and CH3 below it, a hydrogen up and another hydrogen down, and keep them open. That's a repeat unit. You may put them between brackets if you will. If you forgot the brackets, it's okay. It's accepted. Okay. So repeat unit, just take the part from the polymer that when you repeat, you get that large molecule. But a monomer, it has to contain a double bond. That's the main difference between them. Okay. If you add N, Muhammad, then it's the polymer itself. Now, if you take the repeat unit and you put N here as a subscript down below, now it's a polymer. Okay. If you remove the N, it's a repeat unit. Okay. So you don't have to put N. Just try the repeat. If he asks for a repeat unit, just try or pick any two carbons, any consecutive two carbons in an addition polymer, and then it's going to be your repeat unit. Okay. Yes, Muhammad, there is a difference between but1-ene and but2-ene. If you are talking about in the chemical properties, they are doing exactly the same type of reaction. They are doing the exact same type of addition reaction. But if you mean in the structure, yes, they are different in the position of the double bond. And later on, by the way, in next year, you're going to discover more differences between them. But just for time being, you have to know that they are different in structure, and chemically they are the same, but physically they have different properties. But you don't have to get into the exact differences between them. Okay. So Muhammad, as I just mentioned here, N, it means that's a polymer now, because that unit is repeated more than one time. And N, by the way, is a large number. It's not a small number. But here you have that, now it's a monomer. Between brackets, it's a monomer. And also it contains a double bond. That's before the reaction. When the monomers, when they make a reaction, now they produce the polymer, and that unit is repeated with a very large number, and maybe hundreds, maybe thousands, even sometimes millions in some large molecules. Okay. Now, in condensation polymers, we're making whether an amide link or an ester link. An amide link, when you combine between a carboxylic acid and an amine function group. Okay, I mean, when they are condensing together, and every time, by the way, you are making one link, you are removing one water molecule. And we're going to get into some questions like this when we combine between acids and amine functional groups. But if you combine between the carboxylic acid function group and the alkyl function group, you get what's known as ester link. We'll get to that part, don't worry. Okay, I think now it's time for answering some questions. So let me start with questions. Okay. Okay. Perfect. Uh, Listen, even if some points are not 100% clear, when you start answering, solving some questions, I think now the idea is going to be much clearer. Even you can ask me for more explanations if you will. Just leave your question, I'll answer you. And if I answer anything and you feel like you need more explanation, just stop me or send the question number. I will just stop and explain it more. Okay, question one here in this classified part. Proteins are natural polymers, as we mentioned before. Name the type of reaction in which proteins are broken down into amino acids. Okay, guys, remember that proteins are made by a process known as polymerization, and the type of reaction is condensation. So it's condensation polymerization. So if you want to make proteins are natural polymers, and they are made from monomers known as amino acids. And the reaction itself is condensation. And since many amino acids are joining together, so it's condensation polymerization. Now, can we get back from proteins back to the monomers? Yes, and the process is known as hydrolysis. So getting back from the protein into its constituent elements, I mean, if you have a condensation polymer and you want to get back into its monomers, then the process is hydrolysis. So name the process. The process is hydrolysis. I think it would be much better if we used like the blue color. Okay, name two types of substances. Name two types of substance that are used to break down proteins into amino acids. Okay, so that process wouldn't happen unless we have a catalyst, and to be more specific, it's an acid catalyst. So we need an acid catalyst, we need a catalyst, and also that process occurs in presence of enzymes. Guys, to be honest with you, I don't expect that question to show up in the exam because they didn't focus in the new syllabus on that part. You have to know that the process is hydrolysis. However, the two types of substances, I don't expect them to be in the exam. However, just let me go quickly through the question. Now, here he is asking about the amino acids themselves. As you may remember, they are colorless. Name the process used to separate amino acids. So that's said to be chromatography. Chromatography. Name the type of substance used to detect amino acids. Remember, amino acids are colorless. However, we use chromatography. You remember the chromatography? We have a baseline, and then you have here spots. Now, if those spots are not visible to you, then we need what's known as a locating agent. Thank you. Okay, guys. I think now it's worth spending time in making use of the time. So you may just like go ahead of me and send your answers in the in the sorry guys for this comment. It's my daughter. I don't know why she is here. Okay. Okay, so give the symbol of the value used to determine the identity of each amino acid. Okay, listen, guys, it's not part of a syllabus knowing the name of RF value. He just told you that RF value, but it means retardation factor, but you don't have to know the exact meaning of it. I mean, you don't have to know the term retardation factor. You just have to know it's said to be RF value. Remember RF value? It's the distance from traveled by the substance over the distance traveled by the solvent. Let me tell you the whole story once again. We have here like a beaker, and you have to put here baseline, and then you have to put that paper, that chromatography paper here into the solvent. And then you have to look at the solvent front, I mean the top of that solvent. And then you have to look at the point or the spot itself, the distance of the spot over the distance of the solvent front. That gives you what's known as RF values. Okay? Okay, thank you. So question 2. Ethane is an alkane which undergoes a photochemical reaction with chlorine. Guys, just a notice here, he may change chlorine in the exam. The syllabus mentions chlorine clearly. It means he shouldn't use any other halogen, but maybe he would change the halogen. So expect him to use, let's say, bromine or iodine or fluorine. It's the exact same thing. So state Y reaction is described as a photochemical reaction. Photo means something related to light. So why is it a photochemical reaction, guys? Because what condition should you apply here? What's needed with this reaction to be run? I mean, for this reaction to happen. Okay. Do you know, guys? Any of you? Yeah, we need ultraviolet. Thank you, Juman. So we need ultraviolet light. Thank you. Next, part of a synthetic polymer is shown. So here we have a polymer. Yeah, this is a kind of like a good application of what I just mentioned when I explained the addition polymer, and I told you if you asked for the repeat unit. Now, let's say that he's asking for a repeat unit, but he's not asking for a repeat unit. But even if he is asking for a repeat unit, how would you detect the repeat unit? Pick any two consecutive carbon atoms and take them out of the polymer exactly as drawn, and just put them between brackets. Even if you didn't use the brackets, it's okay, it's accepted. So the repeat units here, let me just pick the first two carbons here. So here you have a carbon and that second carbon. The first carbon was carrying C2H5 on the top, and that second carbon hydrogen on the top. Down below we have hydrogen, and down below here we have another hydrogen. Don't forget, if he asks for a repeat unit, keep the ends open. Now it's a repeat unit. If he asks, however, for the monomers, then you have to keep the double bond. Okay, so monomers, keep the double bond. Repeat unit, keep the bonds extended. I mean, keep them open. Is it clear? I hope the idea is clear. However, he's asking you here, state the number of monomer units. How many monomers in this part of a polymer? As I mentioned, every two carbon atoms, they are making one unit. Okay, so here you have one unit, and here you have another unit in that displayed part of a polymer. So how many units do you have? We have just two. Name and draw the structure of the monomer used to make the polymer. Okay, so now he asked for the monomer. However, guys, don't forget, okay, now what if you just took this monomer that I made here? Okay, let's say that was my answer in the exam. Is it correct, guys? Do you think that he's going to give me how many marks we have here? We have 3 marks. Okay, 1 mark for the name and 2 marks for the structure. Okay, I'm going to name it for you. Don't worry about the name, but just let me consider that I left that answer in the in my exam. Would he give me the 2 marks assigned for the structure? What do you think? Do I deserve the 2 marks? Just write the number of marks that you'd expect me to get. Remember, this question is 3 marks. Okay, 1 mark for the name. We're going to. I'm going to write the name now. Don't worry about the name. But we have 2 marks for structure. Do you think that I'm going to get? And he's asking for a monomer, not a repeat unit. So I have to have the double bond. If it's a monomer, I have to get a double bond. Yes, Muhammad. I'm just going to get 1 mark out of 2, and the reason because he asked me to show all the bonds. So yes, my answer is correct. Yes, it's a monomer. However, I didn't show the bonds between carbons and the hydrogens up there. So the full mark answer should be, once again, you have the double bond there, and here you have a carbon, and you should have another carbon. Guys, would it matter if I just put it here, on the top of it, or like beside it? It wouldn't make any difference. So you have to show the bonds between carbon atoms. So since here I ran out of space, let me just take it a bit down here and try to complete the structure. So here I have the 2 carbon atoms, and instead of being C2 combined together as a branch here, I'm just going to show bonds between them. And also I'm going to show all the other bonds. So here we have the 2 hydrogens, and there you have 2 more hydrogens, and there you have the 3 hydrogens. Once again, guys, in the old uh, exams, he used to tell you show all the bonds. However, in the new versions of the exam, he would just ask you for displayed formula. If he asked for displayed, it means you have to show all the bonds. Okay, now I would take the 2 marks. Now I would take 1 mark for getting the monomer correctly, and 1 other mark for getting the bonds, all of them shown between carbon atoms. You may make them this way, I mean that kind of like L shape, or even if you put them in a straight chain, it wouldn't make any difference. It's exactly the same idea, but I kept it this way because it shows the same order of carbon atoms as was drawn on the top. So even if you put them in a straight chain, I mean, if you put the carbon atoms, like, let me just make it in a kind of like in a neat, more organized way. Like here you have the 4 carbon atoms, and instead of being in that L shape, now we have the 4 carbon atoms. And the last 2 carbon atoms, let's say those are carrying the double bond. And here you have the hydrogens, and there you need more hydrogen, and hydrogen up, hydrogen down, and there you have 3 more hydrogens. This is correct, 2 marks. This is correct. However, here you are going to take just 1 mark. Okay, now let me use that last one on the left that I just did here because it's clear for me to name the compound. How many carbon atoms do we have here in this alkene? This is an alkene, and how many carbon atoms do we have? We have 4 carbon atoms. That's why it's an F. F means 2 carbon atoms. And the homologous series or the family here is an alkene. That's why I have to add "ene" to the end. However, here sorry, that's not F. Sorry, guys. Sorry. I was focusing with like the questions on the chat box. Sorry, this 4 carbon atoms is bute. So sorry for that. So it's bute and it's ene. So it should be butene. However, you have to tell me where is your double bond. The double bond on the first carbon, that's why it's bute 1-ene. Okay, Muhammad Tawheed. So that's a bute 1-ene. 1 because the carbon here on the first, the double bond here on the first carbon. Okay? Yeah, thank you, Juman. Thank you for that. I was just focusing on like one of the questions. Okay. Okay. Um, Now, state the empirical formula of the polymer. Empirical formula is defined as the simplest whole number ratio. First, you have to count how many carbon atoms you have and how many total hydrogens you have. We have 4 carbon atoms, so that's C4. I'm not writing the empirical formula. I'm just writing the molecular formula, the total carbons and total hydrogens. And we have 8 hydrogens, so we have C4H8. That's molecular formula. He's not asking for molecular formula, he's asking for the empirical formula. So you have to divide both by 4 to get the simplest ratio. So it's going to be CH2. If you divide both by 4, it's going to be CH2. So now it's the empirical formula. Remember, empirical means simplest whole number ratio. Okay, next. Yeah, thank you, Muhammad. Okay, now question 4, a carboxylic acid. Why? That's a carboxylic acid. Muhammad Siraj, that's I don't know if you asked me that question before or not, but this is the simplest carboxylic acid. In the general formula, remember the general formula of a carboxylic acid is CnH2n plus 1 and COOH. Now, N in a carboxylic acid, in the simplest carboxylic acid, could be 0. So N starts from 0 in a carboxylic acid. So when N is 0, now we are left with HCOOH. That's the molecular formula. You may add also the H's and O's, so it's going to be CH2O2. Both are correct. Okay, now let's answer the questions. Name the carboxylic acid. Since we have 1 carbon atom, it's meth, and then ane, and then oic acid, methanoic acid. It's a carboxylic acid. Right, the molecular formula of the carboxylic acid, Y. You just have to count. I just wrote it up here, if you notice. So it's CH2O2. I just added the atoms, the similar atoms together. Okay. Do you have any questions, guys? Um, yes, there's a difference between them. Um, Someone is asking, is there a difference? Yeah. Um, I don't know who you are, but there's a difference between but1-ene and but2-ene. In case you're talking about making an addition polymer, yeah, there is a difference, and this is a good question actually. Let me just investigate that question here. Okay, guys. So let me take here some space and try to investigate the difference between them when you are trying to make a polymer. So here we have but1-ene. So here you have the double bond on the first carbon and the other 2 carbons there. And but2-ene. We need to fill in the hydrogens for all of the carbons. You know that each carbon should have 4 lines around it. That's why you have to fill them with hydrogens. Okay, now if you want to make a polymer out of these monomers, all what you have to do, you have to focus on the double bond itself, and everything else, put it up or down. Just put them around this double bond. Just focus on the double bond. Double bonds are the positions where monomers are going to connect to themselves. So monomers, in case you have an addition polymer, in case you have an alkene, they connect to themselves through the double bonds. Everything else has to be up or down. So there's going to be a difference if you want to draw the monomer in such a way that you connect them together to make the polymer. So in case you want to make it from but1-ene, that's but1-ene. So now you have to focus on the double bond themselves, and everything has to be up or down around this double bond. So here you have, for this first carbon, a hydrogen up and a hydrogen down. Now for the second carbon, if you look here, now 1 hydrogen up. It doesn't matter, guys, by the way, up or down. And the other carbons, now they are going to be down. So here you have the 2 carbons. You may put them below that carbon on the right side, or you just may, for simplicity, you just add them up. C2H5. If you want to show bonds between them, it's okay, it's accepted. Okay, so that's the monomer of but1-ene. Now, if you look here for the opposite side, if you want to make a monomer of but2-ene, it would look like this. Here you are going to focus on the double bond between the carbon atoms, and for that carbon atom here, I mean for that first asterisk here, one hydrogen up, okay? And then you have, sorry, there should be a hydrogen down here, and here you have CH3, okay, down or up, it doesn't matter, like I may switch between them, CH3 up and hydrogen down, exactly the same idea. Now for that second carbon, you have one hydrogen up or down, it doesn't matter, and the other bond is to again CH3. So that's the monomer when you want to make a polymer out of that but2-ene. So that's but2-ene monomer, and that's but1-ene monomer. So yes, when they are making a polymer, yes, they are going to give you two different polymers. Thank you for that. So just in case he asks you for a difference between them in polymerization, both of them a similarity, both of them will give you an addition polymer. But the but1-ene is going to give you a polymer that's different in structure than but2-ene. Thank you. If you have any other questions, or if anything is not clear, just I may elongate on that part. I may just give you like more information. If it's clear, it's okay. Okay. Um, 9 boys bridge. Okay. You still have 1 year, but thank you for being here today. Okay. Um, I don't understand that. Anyways, okay. Next. Proteins are natural polymers. Proteins contain amide linkages. And name a synthetic polymer. A synthetic polymer, as I just mentioned, nylon. Identify two function groups present in the monomers used to produce synthetic polymers. So what are the function groups? As I mentioned, we have carboxylic acid, and what else should you have? You should have an amine function group. Amine means you have nitrogen bonded to hydrogens. Okay, the hydrogen is going to be removed from the amine function group, and the carboxylic acid is going to, the hydroxyl is going to be removed from the carboxylic acid. A carboxylic acid Y has the structure shown. State the general formula of the carboxylic acids. Okay, guys, here he wants you to look. That question may be confusing to you. Why did he give me the carboxylic acid, a specific carboxylic acid? Now you may just get confused, and because of the stress in the exam, you may just give him the formula of that carboxylic acid. Like you may tell him that it's CH2O2. Unfortunately, you're not going to get the mark out of this because he didn't ask you about the molecular formula of that specific carboxylic acid. He just told you, give me the general formula of carboxylic acids in general. He didn't mention any specific carboxylic acid, but you may argue, but why did he give me that specific carboxylic acid? Just to distract you. So read the question very carefully. He asks you, state the general formula of carboxylic acids. General formula means not for a specific carboxylic acid. And the general formula, as I mentioned before, is CnH2n plus 1 COOH. Remember, N can start from 0, okay? So N can take a value of 0, 1, and so on. Okay, next. Question 7. Ethane is an alkane which undergoes a photochemical reaction with chlorine. Write the general formula of alkanes. Once again, general formula. So It's a distracting piece of information. Sometimes he's giving you an information and then he's asking you for something else. General formula of alkanes, once again, CnH2n plus 2. Question 8. Ethane is an alkane which undergoes a photochemical reaction with chlorine, as shown, again, the same statement. In this reaction, an atom of hydrogen is replaced with a chlorine atom. State the name of this type of organic reaction. Okay, guys. Now, as I mentioned before, that reaction is a substitution and photochemical. Since already he mentioned photochemical to you, you don't have to repeat it again. So just tell him the other term, which is substitution. So that's a substitution reaction. Okay, thank you. Next, in this reaction, one of the products is chloroethane. Name the other product, and that's a common question. So let me get back to the reaction again. So that's chloroethane. Now, what's the name of that other product? An easy question, such an easy question. That's hydrogen chloride. Remember, HCl, when it's a gas, it's a hydrogen chloride. If it's aqueous, it's hydrochloric acid. Okay, since it's a gas, it's hydrogen chloride. So that's hydrogen chloride. Such an easy question. Next, ethane C2H2. Sorry, ethene C2H4 is an alkene. Write the general formula of alkenes. So CnH2n. If you add it to, it's going to be an alkane, but he's just asking for alkenes. Ester Y has the structure shown. Describe what's meant by the term structural isomer. This question that I expect to show up in your exam. The definition of a structural isomer. You have to learn it. You have to learn it. It's an important definition that would show up. So once again, a structural isomers, you have to tell me, because it's 2 marks, you have to tell me what's same and what's different. Structural isomers, they are compounds or molecules that have the same molecular formulae, or molecular formula, sorry, I should say molecular, because it's one, so it has to be a formula. So molecular formula, but they are different in structural formulae or formulas. Next, name a carboxylic acid which is a structural isomer of ester Y. Okay, now remember, an ester has 2 parts. It has an alkyl part and it has an acid part. How would you identify the alkyl part and the acid part? Alkyl part always includes the oxygen with it. Okay, that's an alkyl part. So that comes from an alkyl parent. The acid part is the part that carries the C double bond C. So that's the acid part. So that comes from the acid. So you have an acid part and you have an alkyl part. Now, name the carboxylic acid in that ester. So you have to just complete the acid that has 1 carbon of it, 1 carbon in an acid. Remember, once again, that's a methanoic acid. So that's a methanoic. He's not asking for the structure, by the way. I just drew it for you, but he's not asking for it. I'm just to clarify the question. He wants name, and if he asks you for a name and you give him the structure, he wouldn't give you the mark for that, unfortunately. If it's a name, you have to name it. So that's methanoic acid. Methanoic acid. Methanoic acid. Next. Thank you, Muhammad Siraj. Muhammad Siraj, you are the most active here today. Okay. Okay. Next. Ethene is an alkene which reacts with bromine as shown in the equation. Remember, that's an addition reaction. Describe color change. This is a very common question also. So color changes from brown, or you may say orange, to colorless. So from brown or orange to colorless. That's the color change. And remember, that's a test for unsaturation. That's a test for alkenes. Ethene is an alkene which reacts with bromine as shown in the equation. In this reaction, only one product is formed from two reactants. Name this type of organic reaction. Now, this could be, this same question could be a definition. Like he may give you the definition and ask you about the term used for that definition or vice versa. So that's a definition of an addition reaction. Okay, so an addition reaction is defined as a chemical reaction that only, or that forms only one product, okay, from two reactants. So you start with two reactants, they combine together, they react together, and they give you only one product. That's the definition of an addition reaction. Next, ester Y has the structure shown. Ester Y can be made by reacting two organic compounds together. Remember, once again, alkyl part, carboxylic acid part, and once again remember, the alkyl part is the part that contains the oxygen with it. So that's alkyl part, and the carboxylic acid part is the other part that contains the C double bond C. In other words, count how many carbons you have in that acid part, and that's going to be your acid. Remember, meth for 1 carbon, eth for 2 carbons, prop 3, and bute 4. And don't forget to add anoic acid. Okay, now he's asking you, name the compound and draw their structures. Name the compounds and draw their structures. Okay, so name the compounds. I mean, you have to name the acid and you have to name the alcohol and you have to draw each of them. So first, let me start with the structure of one of the two parts. Let me start with the acid part. The structure should be, here you have 1 carbon. By the way, guys, my tip is, if you want to draw any structure, just put the carbon backbone first and then put everything you need around it. It depends on the homologous series or the family. Like, let's say I'm drawing a structure of a carboxylic acid that has 1 carbon. I start with carbon. Just put all the carbons you have and then fill whatever you want to complete this compound with. Like, you want it to be a carboxylic acid, then I have to add to that only carbon, I have to add a double bond O, and then I have to add OH also. That's a functional group of a carboxylic acid, and we don't have any other carbons, so you should put here a hydrogen. That's the structure. The name of it, since, as I mentioned, since you have just 1 carbon, it's meth, okay? So it's meth, and then anoic acid. Methanoic acid. Now, the structure of the alcohol part. Also, if you look here for the alcohol, it has just 1 carbon. Always I start with the carbon backbone. Since I have 1 carbon, and then I have to add everything to make it an alcohol. Then I have to add the function group OH, and then I have to fill in the hydrogens around that carbon. So that's meth. Once again, it's a 1 carbon. And then ane, because single bonds around carbons, and then ol, methanol. Okay. Any questions? Okay. Imad, I think Imad, you are in grade 11, but you are welcome here. Okay, guys. How come 1,000 guys? Did you bring your family with you? Anyway, they are welcome. Okay, so question 14. Question 14. When alcohols react with carboxylic acids, esters are produced. The structure of ester X is shown. Name ester X. Now he wants the name of the ester. He doesn't want the components of the ester. I mean, he's not asking for the alcohol part and carboxylic acid part, by the way. But let me just, for clarity, work on. However, he's not asking for that specific question. But let me just work out also this specific ester here. Once again, you have the alcohol. Remember, alcohol contains the oxygen, so that's alcohol part, and everything else that contains the C double bond O, that's carboxylic acid. Okay, so here you have 2 carbons in the alcohol part. 2 means eth, and then anol, so ethanol. And the carboxylic acid, you have 4 carbons. That's why it's bute, and then anoic acid, so butanoic acid. Okay, now he wants the name of the ester. Remember, in the name of the ester, you have to start with the alcohol parts. You have to start with the name of the alcohol. How many carbons you have? You have 2 carbons. That's F. And then Yes, Juman, thank you. It's ethyl. The alcohol part is correct. Ethyl. However, since it's a 1 mark, unfortunately, if you didn't complete the whole name correctly, he's going to take that mark. So it's ethyl because you have 2 carbons, and then you have 4 carbons in the acid part, so it's bute. And then you have to add anoic to it. So it's butanoic. Sorry, not anoic, sorry, butanoate. Butanoate. Okay, butanoate. So ethyl butanoate. So once again, guys, you have to add YL to the root of the alcohol, and you have to add anoate to the root. Root means, I mean, carbons you have. Okay, so the root here in the alcohol, you have 2 carbons. That's why it's eth. That's root. Okay, and YL to that root. And then in the acid part, you have 4 carbons. That's bute. And the suffix, I mean, the ending should be anoate. Okay, so ethyl butanoate. Thank you. Sorry, Muhammad Ramadan. Can you please put your question back again, Muhammad? I didn't see it. Sorry for that. Mahmoud Adnan. I want you for sure, Mahmoud. And I am honored to have you, Mahmoud. Everyone, this session is free for all, Mahmoud. Even you, if you are not one of my students, I'm honored to have you. Um, if you are in grade 9, you're coming to me next year. So yes, I'm honored to have you. Sure, Imad. I'll do, Imad. Um, Cars 24. Um, I can't see your question. Sorry, Muhammad, I can't see your question. I tried to get it, but I can't see it. Just put it again, Muhammad. Nice to meet you, Mahmoud Adnan. Muhammad Adnan, sorry, Muhammad Adnan. Uh, uh, Sorry, W? What do you mean by W? Was it a question that I missed? What do you mean, guys, by W? I can't get you. All of you are sending me W. Uh, well, I can't get it. Ah, W means when. Oh, thank you. Thank you, Hamza, for letting me know that. Okay. Okay, you have codes. Thank you. I didn't know that. Thank you. Okay. Give the name of the alcohol and carboxylic acid. So once again, as I mentioned before, in the alcohol you have 2 carbons, so it has to be ethanol. Sorry, I should turn into blue. Ethanol. And carboxylic acid, you have 4 carbons, so it's butanoic acid. Butanoic acid. Next, uh, question 15. Ethanol is a member of the alcohol homologous series. Members of the same homologous series have the same general formula. State the general formula of alcohols. As I mentioned, the 4 general formula, you have to memorize them. And in the exam, he would ask you for one of them: alkane, alkene, alcohols, and carboxylic acids. Ester, you don't have to memorize. So for alcohols, it's CnH, 2N plus 1 OH. Okay, next. State 2 general characteristics other than same general form. Remember, guys, I told you we have 3 and two differences. Okay, they are the same general formula. He already mentioned that, so he wants something else. And they are the same chemical properties, and they are the same functional group. Okay, so let me just mention they are the same functional group, and they are the same general, sorry, it was mentioned general formula. So let me just mention chemical properties. Chemical properties. And you may mention properties. And you may mention that they are, or they differ from one member to another, or to the next by CH2 unit, or you may say that they are showing, or they show or display trend. Trend means gradual and expected. A trend in physical properties. Physical properties. I mean, they are different in physical properties. Also, you may mention the point of having CH2 unit separating between or a difference between one member to the next member. Okay. Who's Muhammad Ramadan? The actor? Okay. Okay, next. One alcohol containing three carbons or three carbon atoms is propan 1-ol. Draw the structure of the other alcohol containing three carbon atoms. Show all the atoms and all the bonds. In the recent exams, he would just tell you that I want the displayed formula. Displayed means he wants everything. He wants all the atoms and all the bonds. And name the alcohol you have drawn. So once again, we have an alcohol that has three carbon atoms, prop-1-ol, and he's telling you that there is one other alcohol containing three carbon atom, and he wants that other alcohol. Okay, guys, he's not asking for propan 1-ol, he's asking for the other structural isomer of it. It means just change the position of the functional group. And instead of being on the first carbon, just make it on the middle carbon. So once again, you have the three carbon atoms here. As I mentioned, I always start with the carbon backbone, and then I have to put everything else I need to put. Like I have to put first the function group OH, and then I have to fill in the hydrogens to each of these carbons. So here you have three hydrogens around this first carbon, and there you have one more hydrogen, and there you have three other hydrogens. So the name is, since you have three, is prop, pan, and then you have 2-ol. So once again, ol means OH, and it's positioned on carbon number 2. That's why you put here 2 before it. And prop, because you have three carbon atoms and everything is singly bonded between carbon atoms. That's why it's N. So propan 2-ol. Next, here you have a list of substances, and then he is asking you, state which substance is used as a fuel. The answer is clearly ethanol. Remember, I told you that ethanol has two uses. It can be used as a solvent, or it can be used as a fuel. So the answer is ethanol. Next, list a substance. A list of substance is shown. Again, the same list of substance, and the question is, state which substances are the two products of fermentation. Now, fermentation, you remember fermentation is one way of getting alcohols, and he wants the two substances that are produced. So clearly you're going to produce an alcohol. So it's ethanol. So here you have ethanol. That's an alcohol, the only alcohol you have in that list. So it's ethanol. And as you mentioned before, you're going to produce carbon dioxide. It's here. So carbon dioxide. And of course, it has an impact on the environment. It's a greenhouse gas, carbon dioxide. Okay, next, question 18. When carboxylic acids react with alcohols, esters are produced. The formula of the ester X is given. Name the ester X. Okay, now, remember that the part that has oxygen in it, that's the alcohol part, since you have one carbon, so that's alcohol part here, the part that contains oxygen in it. And the other oxygen, it's bonded to carbon through a double bond. That's the acid part. That's alkyl part. That's an alkyl part, and that's an acid part. So name ester X. So since you have one carbon, can you give me the name for Muhammad's in the chat? Yes, all of them are welcome. Okay, so it's meth. I remember the alcohol always ends with YL in an ester. Propyl ethanoate. Can you give me? Can you just take your time, Muhammad? I know you can get it, but just take your time. Remember, Muhammad, you have to start with the alcohol part. Okay, now I know that sometimes it's confusing when you have it in this written form when it's not displayed. I know maybe it's confusing to you, but always the second oxygen is the oxygen of the alcohol. Okay, thank you. So it's methyl, and then in the acid part we have three carbons, so it's propanoate. Okay, so prop because three carbons in the acid part, always alcohol in the first part, and then acid second part. Now, give the name of the carboxylic acid and the alcohol that react together to produce ester X. So the carboxylic acid, it was a carboxylic acid with three carbons, is prop, and since it's an acid, propanoic acid. Propanoic acid. And the alcohol is methanol. 19. Ethanoic acid is a member of the homologous series of carboxylic acids. State the general formula of this homologous series. Once again, CnH2n plus 1 COOH. Remember, N could be 0 for the first member of the carboxylic acids. Uh, so sorry. Yeah, I didn't notice that. Sorry. Yes, Kawasagi. Yeah, thank you. Anyways, I can't read the name, but thank you. Yes, I didn't count them carefully. There are four carbons. Yes, I didn't notice that there are four, so it's bute. So sorry for this, guys. Yeah, I should change it into bute. Thank you. Okay, so four means bute, so it should be bute weight, and of course here also it should be bute, not prop. So again, once again, bute means four carbons. Thank you. Butanoic acid. Thank you. Yeah. Sorry, I didn't notice that there were four carbon atoms. Yeah, I just counted them three. Sorry, I didn't notice that. My bad. Okay, next. So butanoic acid and methyl butanoate. Yeah, thank you. Question 20. Um, Ethanoic acid, CH3COOH, is a carboxylic acid. Though the structure of the carboxylic acid containing three carbon atoms show all the atoms and all the bonds. So once again, in the recent exams, he would say displayed formulae or displayed formula. So since it's an ethanoic acid, though the structure of carboxylic containing three carbon atoms. Okay, here, guys, he's asking for three carbon atoms, and he's giving you the two carbon atoms as a kind of like as a guidance to you, and he wants all the atoms and all the bonds. First, you should start with the carbon backbone. You have three carbons, it means put them first, and then put the functional group that you want, or create the functional group that you're working with. Since it's a carboxylic acid, it's going to be double bond O here, and O and H. And then fill in the hydrogens. So here you don't have any hydrogen because already you have four bonds, and here you have to add a hydrogen up, hydrogen down, and hydrogens here everywhere. So that's the displayed formula of a carboxylic acid with three carbon atoms. Since you have three carbon atoms, it's propanoic acid. Thank you. Really? Muhammad Ramadan in my okay. Thank you, Muhammad Tawheed. But don't forget, you have to show all the bonds between atoms. Thank you. Once again, we have a list, and then he's asking you answer the questions using the substances in the list. Okay, so don't bring anything outside the list. Each substance may be used once, more than once, or not at all. State which substance is a product of respiration. Of course, clearly carbon dioxide, and is such an easy question. Carbon dioxide. The main constituent of hematite, remember, hematite is the ore of iron. So the answer is iron 3 oxide. Okay, so iron 3 oxide. Next, an element which has a sulfate that's used to test for water. Remember, testing for water, we can do it through uh, two substances or two cations, cobalt and copper. If you looked here for cobalt or cobalt chloride, to be more specific, you can see it. So just you're left with copper, and I can see copper here, okay? But not copper by itself, but copper sulfate. Okay? He told you sulfate of it, okay? So the answer is copper. Colorless toxic gas. Colorless toxic gas, so we're looking for carbon monoxide. Yes, perfect. Carbon monoxide. Carbon monoxide. Reactant in fermentation. Yeah, reactant or reagent in fermentation. What do you need in fermentation? If you check here the list, what do we need in fermentation? Of course, in fermentation, we need an alcohol. So do we have here any alcohol? Sorry, in fermentation, we produce an alcohol, but we need a glucose. And in presence of like yeast, we don't have yeast, so we have glucose. So the answer is glucose. So glucose. Next, a reducing agent in the extraction of iron. Back again, that's carbon monoxide. So carbon monoxide. A conductor of electricity when solid. So we're looking for a metal. So I think the only metal we have, yes, it's copper. Back again, so it's copper. Okay, copper. It can't be an ionic compound, by the way. You know that ionic compounds, they can conduct electricity only when molten or in aqueous. But the substance that can conduct electricity when solid, that's only a metal. So we're looking for just a metal. And finally, a gas that is approximately 21% of clean dry air. 21%, clearly that's oxygen. So let's see, do we have, yeah, we have oxygen here. So the answer is oxygen. So the answer is oxygen. Okay, next. Now we have a polymer. Yes, that's a question that I was looking for. Look, guys, if you look at the link between monomers and you see and you get them with the same exact order, like if you look here for oxygen and carbon, oxygen, carbon, oxygen, carbon, oxygen, carbon, they are exactly the same repeating order. I mean, they are not flipped or alternating. It means both of them came from the same monomer. I mean, you have the like one monomer, and that one monomer carries the two functional group. The same monomer carries the two functional group. I'm going to repeat once again. Maybe that idea is not clear yet, so let me repeat once again. You have two types of questions, or you have two types, let's say, of condensation polymers. A condensation polymer that produces a link that's exactly the same order. Like, look here, oxygen, carbon, oxygen, carbon. Okay, they are exactly the same repeating order. Now, that polymer came from a monomer, just a single monomer that carries both functional groups. Remember that condensation polymers, they need to be created. A condensation polymer needs two different functional groups, and both of them on the same monomer. Okay, if it's not clear, just bear with me. Let me search for another example. Yeah, let's look at this example here. Here you have carbon, oxygen, oxygen, carbon, carbon, oxygen. So they are alternating. I mean, they are different. Like the order here is carbon first and then oxygen and carbon, which is the opposite, the reverse. And then it's reversing again, carbon, oxygen. If you have that kind of like alternating pattern, I mean, they are different in the arrangement. They came from two different monomers. So let me just make it such an easy like this. Uh, like if they are the same order, they came from a single same. They are same. So on the same monomer, you have the two functions. So same, same. And if they are alternating or different in different order, if they are in different orders, so they came from two different isomers. Sorry, I should say monomers, two different monomers. Okay, so if the order is the same, they came from the same monomer. If the order is different, they came from two different monomers. Okay, I hope the idea is clear, but even let me make it clear for you. Now you have the same order. It means both functional groups, they are on the same monomer. I mean, you have a single type of monomer. So the monomer here should be, it should look like this. Here you have a box which represents whatever carbon atom or carbon chain you have, or carbon a part here. And then the most important point on the edges, you may also put a hash here, doesn't matter. And here you have one end is an alkyl functional group, and the other end is a carboxylic acid, an acid functional group. So on one monomer, you have the two functional groups. That gives you a kind of like the same pattern: oxygen, carbon, oxygen, carbon, oxygen, carbon, oxygen, carbon, and so on. Now, what if you have that kind of like alternating pattern? Carbon, oxygen, oxygen, carbon, carbon, oxygen, oxygen, carbon. It means you have two different monomers. For one of them, I'm going to use a dashed or hashed box, and for the other one, I'm going to use an empty box. Okay, now for this dark one, it has the OH, and it's repeated twice on the same monomer, but here you have the other function group. Like here you have C double bond O, OH, and the same here, C double bond O, OH. Okay, so once again, guys, um, um, uh, okay, do you have any questions? Yeah, thank you, Muhammad Siraj. Dicarboxylic acid. Yes, exactly. And diol, that's said to be diol, and that's said to be dicarboxylic acid. So diol and dicarboxylic acid, if they give you an alternating pattern, carbon, oxygen, oxygen, carbon, carbon, oxygen. But if you have the same pattern or the same order of the atoms in the link, then the two function groups, they are found on the same unit. I mean the same monomer. So here you have one type of monomer but carries the two different function group. I hope the idea is clear, guys. If it's not clear, just let me know. Just write anything in the chat box. Okay, Marwan. I only have one Marwan in my class, so I think it's you. Yeah, I know that you are genuine. Okay, thank you. So state the number of different types of monomers needed to make a polymer Y. Yes, it's a catalyst. Yes, Marwan Sayed. Yes, it's a catalyst. So okay, I don't know which is which, but we have Marwan al-Millat and we have Marwan al-Sayed. Okay, both of you are welcome. So, okay, Marwan, so how many types of monomers do we have? Since they are the same order, they came from the same monomer, so you have just one monomer, okay? But for that other question, guys, that question down below here, you have two different monomers. One of them is diol and the other one is dicarboxylic acid. So the answer here, you have two different monomers. But by the way, he's not asking for how many monomers. It's not the question here. Sorry, Marwan. Wallah, sorry. I'm sorry. You mean, Ali, you are onions? I don't know what does it mean, but anyways, uh, I hope it's something good. Okay, next. Part of polymer Z has the structure shown. Remember, guys, if you have if you have an addition polymer, always look at any two consecutive carbons and take them out. That gives you the repeat unit. Draw and name the structure of the monomer. He who wants monomer. He doesn't want a repeat unit. Monomer means you have to include a double bond, and he wants you to show all the bonds. I mean, he wants a displayed formula. So once again, pick any two. Let's say that I'm going to pick those two carbon atoms here at the very beginning of that part of the polymer, but you have to show all the bonds between atoms. So here you have the two carbon atoms, the main two carbon atoms, and up there you have, don't forget, it's a monomer, you have to include a double bond, and here you have another carbon, and then I have to show the bonds between carbons and the hydrogens to make it a displayed formula. And here a hydrogen, and down below we have another carbon with three other hydrogens, and here we still need one more hydrogen. So that's the monomer. If you want to make it as a straight chain, it wouldn't make any difference, guys, by the way, but you can do it like this. You can put all the carbon atoms in one chain, like here you have a carbon atom. It's exactly the same. You don't have to repeat it in the exam. I'm just repeating it in front of you to convince you that it wouldn't make any difference, by the way. But in the exam, you don't have to repeat that, okay? And then you have here the other carbon atoms, here another hydrogen, and double bond, and C, and hydrogen there, and then you have the last carbon atom with three hydrogens in it. Now, if you want to name it, you have four carbon atoms, so that's bute, and you have a double bond, that's ene, but that double bond in the middle carbon, so it's bute 2 ene, okay? Bute 2 ene. Any questions? um, yeah, thank you. Thank you, Muhammad Tawheed. Okay, thank you. Next, name the chemical process or the chemical reaction used to make the monomer that forms polymer Z. Okay, now he's interested in what chemical process would make that alkene. You know, alkenes, they can come from longer alkanes by a process known as cracking. Yes, perfect. Remember that map I gave you in the very beginning? I mean that scheme. And by the way, in the exam, he may give you part of that scheme. Let me just show it again to you. Once again, the scheme was here. Yes, in the very beginning here we have the scheme. Yeah, remember, once again, you can get into alkenes from alkanes by a process known as cracking. Okay? Yeah, perfect. So back to the questions. Next, again, you have the polymer, but remember that polymer has an alternating pattern. I mean, the order of the bonds on the order of the atoms is flipped from one link to the next. So how many molecules of water are produced? Remember, each link removes one water molecule. Since here you have three links, that's the first link, by the way, it's called an ester link, and that's another link. So here you have another water molecule, and here you have a third last link in that part of the polymer. So you have three water molecules. Next, complete the structures of the two monomers used to make polymer X. So here you have the polymer X, and he wants you to, actually, I did them here on the top. If you can, like, let me just cut and paste, okay, just to save some time. So that's one. Of course, you have to complete them according to the table. Not to confuse you, let me just, it will just take a few seconds. So quickly I can do it. So here you have the first box. I'm going to make it for the dicarboxylic acid. By the way, you may call it dioic acid, dicarboxylic acid or dioic acid. So C double bond O, O, H, and from that side you have C double bond O, O, H, and for that box here you have O, H, and down below you have O, H. Okay, so that's dioic or dicarboxylic acid, and that's diol. Next, what type of condensation polymer is X. X is it a polyester or polyamide? Anyone? Okay, guys, sorry for that. For that last comment. Uh, I think Ali. Okay, Ali Ashri. I think he. Okay, Hannah. He didn't want to say anything bad to me. Sorry, guys. She's my daughter, and she thought like one of you is like saying a bad word for me. He just want to say like he's like the original one, but sorry for that, guys. Okay, yes, it's polyester. Polyester. Yeah, it's a polyester. Thank you. Thank you, Muhammad Tawheed, Muhammad Adnan. Thank you. No problem, Muhammad. I'll send you. Okay. Now, this is part of the scheme I showed to you in the very beginning that connects all the ideas and all the homologous series we have. And he may give you part of that scheme and ask you some of the questions. Let me quickly answer the questions. Guys, I'm going to move faster. If you have any question, just stop me. I'm going to give you a break once we finish that first part. I divided organic into two parts. Once I finish that part, I will just give you a break. So quickly, let me state the reagent and conditions. Look here, reagent means reactant, conditions means like pressure, temperature, catalyst. Okay, in reaction 4, if you look here at reaction 4, it's change of an alkene into an alkane. So change from alkene from double into single. In order to make that, guys, remember what do we need? You need to break the double bond, and if you want to do that, you have to use hydrogen. So the reagent, I mean the reactant, is hydrogen. That's a reagent. But the conditions you need, conditions that you need. Remember that addition reaction wouldn't happen unless you have high temperature, and also you need a catalyst and a catalyst. And by the way, the catalyst is nickel, but you don't have to mention the name of the catalyst in the exam. I prefer if you mention it because it's in the new syllabus, nickel catalyst. Okay, so a nickel catalyst. What if in the exam he asks you to suggest a catalyst, and other than nickel, just pick any close transition element to nickel? It would work perfectly. Okay, thank you. Um, okay, Muhammad Muhammad Siraj. Okay, Muhammad Siraj, a phosphoric acid. It's not for addition of hydrogen. It's for addition of steam. Okay, but you don't have to mention the name of the acid, phosphoric acid. Just say an acid catalyst. For addition of steam, you need an acid catalyst, 300 degrees Celsius and 60 atm. Ultraviolet, it's just in substitution, Muhammad Ramadan. It's just in substitution of an alkene. Okay. Uh, okay. You may pick an element like nickel. Okay. I don't expect him to ask you about to suggest. Maybe he would guide you somehow, but I think if he asks for a specific type of element, just mention nickel. You don't have to get into don't worry, Muhammad. I'm going to give you like a break. Just I'm going to get quickly to that one or two more questions, and then I'm going to give you like 10 minutes break. Okay, state the general formula of alkanes. We said that before, CnH2n plus 2. Now we have again the same scheme and identify the other reagent in reaction 5. So reaction 5 here is from ethanol to compound C. And he's telling you that ethanol is oxidized, so he needs oxidation. What's the reagent in oxidation? Okay, guys, anyone? Any ideas? Yeah, don't worry, Kawasagi. Don't worry, just I'm going to give you a break. No, today's session is actually 10 hours. uh, We are in the third hour. I'm going to give you 10 minutes break, but just let me finish at least this question. So identify the reagent to make to undergo oxidation of ethanol. Anyone? No problem, Muhammad Adnan. Yeah, perfect. It's potassium manganate, but it's not a catalyst. It's a reagent. Okay, it's okay. Of course, I'm kidding. It's not 10 hours, but at least let me just go with one of the complete exams with you. Like we can go through, let's say March 2025, the last exam. We can just quickly go through it, and because actually I need to give you some comments on that exam. Okay, so the reagent is potassium manganate. Potassium manganate. Okay, and the oxidation number is 7 if you want to mention it, and it's aqueous, acidified aqueous potassium manganate. Name the homologous series compound. Name the homologous series compound C belongs to. Compound C. So compound C, if you oxidize ethanol, of course, it's going to give you a carboxylic acid. So the answer is carboxylic acid. Draw the structure of compound C. And now, if you have F, it means 2 carbon atoms, and then you are going to make it as a carboxylic acid. Guys, remember, always start with the carbon backbone and then add whatever function group you want to make. So here I want it to be a carboxylic acid, so it's going to be O up there, okay? And then O um, and H, and here you have hydrogen, hydrogen, and hydrogen. Okay, guys? Um, Okay. Um, Again, the same mark scheme, we have it repeated more than once. I think now it's time to take a break. If you agree, just send me. Okay, break, 10 minutes break. What do you think? Okay. Um, okay, so break, okay. Yes, the question that was similar to that, Muhammad Siraj, it was zinc. Zinc actually is not one of the transition elements. It doesn't have variable oxidation states. But the reason why zinc isn't why zinc is not a transition element, you'll take it later on in grade 11. So that's why I don't expect you to know the reason. However, it's not zinc. Just choose anything that's very close to nickel in the periodic table. That would be the best answer. Okay, let's take 10 minutes break now. It's 6:11, so let's get back at 6, let's say 20. Okay, I wouldn't stop this stream. I will keep it. You can just mute it and get back after 10 minutes. So take a 10 minutes break, and then we're going to continue. Just few more questions, and then we're going to get into one full exam. Maybe the exam is going to be the March. I'm not sure, but I'm just going to pick any. Just suggest an exam, guys, and we can take it. I'll try to do it in 30 minutes. Just I'm going to go quickly through it, and if you have any questions, you may stop me and ask for more clarification. Okay, just 10 minutes. Sorry, Isa, because we need to finish the full exam. I don't want to exceed 3 hours, so just 10 minutes will be enough to get back and then complete some more questions and then get into a full exam. Thank you. 10 minutes, I'll be back. I'm just going to mute the stream. You may leave your question, guys. I'll get back to all of your questions, but the stream is going to go online. I'm not going to stop it. I'm just going to mute it for 10 minutes, and then I'm going to get back. Okay? So we're going to meet at 6, let's say 25. Okay? 25, 10 minutes, more than 10 minutes. Actually, it's 13 minutes. Okay. So see you in 10 minutes. Bye. Hello, guys. Welcome back again. I just picked March 2025 paper 4. So let me quickly go through it. I'll try to just give you the answers quickly and directly. Just in case by mistake, I didn't notice any of the questions, or even I did any mistake. Just follow me. If you feel like any of my answers looks weird to you, just leave a comment in the chat box. Just give me a warning. Otherwise, if everything is fine with you and you understand everything and everything is clear, it's okay. I'll try to finish it quickly in 30 minutes. I'll try to do my best to do that. I'm not sure if I can achieve that kind of target. You know, the timing is an hour and 15 minutes, but I'll try to go quickly through it. Without any further ado, let me just quickly answer the first question. He's asking only to use some numbers. Okay, so numbers only. Percentage of oxygen, you have to memorize all of these numbers, guys. By the way, percentage of oxygen, it's 21%. You don't have to write anything else, even the symbol of percent, just 21. Typical operating temperature for Haber process, that's 450. Number of atoms in a diatomic, di means 2, so it's very clear, straightforward, such an easy. Maximum number of electrons in a second electron shell of any atom is 8. And then the number of hydrogen atoms in the alkane with 7 carbon atoms, just apply the general formula C7H16, so it's going to be 16. And finally, number of particles in 1 mole, that's Avogadro's constant or Avogadro's number, that's 6.02 times 10 to the power of 23. Next, this question is about ionic compounds. State what's meant by the term ionic bond. Okay, guys, so that's a clear definition. He wants the definition of ionic bonds. I expect this year to get one of the 8 definitions, the top most common definitions in the IGCSE chemistry. I'm going to mention them at the very end of today's session. Just remind me, guys, before I end, to give you the most important 8 definitions. I'm not going to tell you the definitions like one by like exactly the meaning of them, but just I'm going to tell you the terms, and you collect all of them in one page. It will save a lot of effort to you. So what's meant by an ionic bond? So it's electrostatic, strong electrostatic. All of the bonds, by the way, covalent, ionic, metallic, they are strong electrostatic attraction between oppositely charged ions, cations, and anions. Electrostatic attraction between oppositely charged ions. Okay, electrostatic attraction between oppositely charged ions. Oppositely charged ions. Okay, next. Potassium sulfide, K2S, he wants the dot and cross diagram. Remember to count the number of electrons in potassium. Potassium in a neutral atom, it has 19 electrons. You have now 10 of them, 10 dots, so you still need one more shell. So you have to make a neat and clear shell. And then you have to fill the 8 electrons of it as dots, because he chose dots, and 1 electron is lost. That's why it's 1 positive charge. Now for sulfur, if you look at the number of electrons in a neutral atom of sulfur, it's 16. So you still need to add 1 more shell, and then you have to use crosses for sulfur. So you have already 10. You still need 6 more crosses, and the 2 other electrons will come as dots from the 2 potassium ions, and since it gained 2 electrons, it should carry 2 negative charges. And here again, the same potassium, you have to repeat it. Just copy and paste it once again. So once again, you have 8 outer electrons, and it has lost 1 of its electrons, so that's why it's 1 positive charge. Next, here you have a diagram of the of part of the ionic lattice, and he started giving you one of the ions. He gave it to you as negative, and he wants you to just alternate between negatives and positives. So the direct to it should be positive, and then the direct of it should be negative, and then positive. Just alternate between them, positive, negative, positive, negative. That's positive, it should be connected to a negative, and so on. That's positive, negative, positive. So it's just like a game, alternate between positives and negatives. The name of a positive ion, that's a cation. Uh, Now, if you have an ionic compound and you decompose it by passage of an electric current in an using inert electrodes, state the name of this process. This is a definition of electrolysis. Electrolysis. But sometimes it could be aqueous, but here you have the ionic part of it. Okay, and next you have to give him the ionic half equation for the decomposition of molten potassium bromide, and he wants the half equation as the anode. Anode is a positive electrode. That's why you have to to attract the negative ion to it. So you have to use here the bromide ion, and you have to use two of it in order to produce the diatomic bromine molecule, and then you have to release two electrons. Next, at the negative electrode, at the cathode, in case you have dilute aqueous potassium bromide. Now, potassium, K, Br, K is positive, Br is negative. Aqueous means you have hydrogen and hydroxide. Since it's dilute, it means the hydroxide is going to discharge as oxygen at the anode, and the hydrogen is going to discharge, because potassium is very reactive and hydrogen is less reactive, as hydrogen gas at the cathode. Now he's asking for the negative electrode anode, so it has to be the hydrogen. Okay, the negative electrode cathode. Sorry, the negative electrode cathode. Hydrogen is going to discharge at it, so the answer is hydrogen. Observation. Now remember, product means what the name of the substance exactly, but observation is like effervescence, like bubbles, okay, or you have like fumes, like brown fumes of bromine gas. Those are observations, something that you can see with your eyes. So here the observation is effervescence. Or you may say fizzing or bubbling. So all of these words are synonyms. So effervescence or bubbling or bubbles or fizzing, they are exactly the same meaning. Products at the positive anode. So at the positive anode, then you have the hydroxide is going to discharge as oxygen gas. So the answer is oxygen. And with oxygen, I advise you guys to learn the equation of the discharge of hydroxide. You know that it produces oxygen gas, and in addition to that, it produces water. Okay, so oxygen molecule and two water molecules. Okay, observations at the positive electrode. Once again, since you have a gas, it has to be effervescence or bubbling or fizzing. So it's effervescence or bubbling or fizzing, the same meaning. Question 3. Chlorine is a member of the group of halogens. Now he's asking for the number of group. That's group 7. You may write it in Roman as VII, or you may write it as 7. Okay, both are correct. Now, the next, state how many halogens there are in this group. This question, guys, look, I always advise you, because the science is getting always updates, so I really advise you, if you can, take a quick look at the periodic table that's given to you, because if you look here at this version of the periodic table, yes, perfect. Now this is group 7, and if you count how many elements in this group, you have 1, 2, 3, 4, 5. He used before to give you 5, and that element is a brand new one. We have only in the latest versions of the periodic tables. So according to that latest version, we have 6. So if this question came in previous versions of the exam, you would count 1, 2, 3, 4, 5. You would just write 5, but according to the version you have with you in hand, that's 6. Okay. Okay. Is there any mistake? Because here I got almost maybe 30 comments I didn't read, but I think if everything is fine, guys, everything is fine. I hope everything's fine. I hope I didn't make any mistakes. Yeah, I was answering the exam very quickly, but I hope no mistakes. Okay. Anyways, state how many. If there is a mistake, just repeat your comment, because I have lots of comments. I can't read all of them. State how many halogens there are in this group. So if you count how many elements you have, of course you have 6 of them according to the latest version you have in hand. If you have an older version, of course you have to refer to the version that was given in that specific exam. So in March 2025, he gave him a version of the periodic table that has 6 halogens in it. Okay, suggest the identity of a halogen which has the highest density. Yes, remember guys that density, um, you know that density, as you move down, density increases. So you have to choose the furthest element down. If you look here once again at the furthest element down, let me quickly go to the last page. Yeah, perfect. Now, as you may see here, it's tennessine. Okay, even if you don't know the name of the element, it will be given to you in the exam. So it's tennessine. So the answer for this question, you have to choose the furthest element down in that group, which is tennessine. So the answer is tennessine. So tennessine. And the most reactive, remember reactivity, as you go down, reactivity decreases. That's why you have to choose the highest element in that group. So it's fluorine. So fluorine. Next, state the name of the negative ions or anions formed by halogens. What do you call them? Halogens. When they are ions, they are called halide. Okay, so halides, or a halide ion for singular. State how many occupied electron shells there are in a bromine atom. You have to check again. Once again, you have to check the periodic table and look at the period number. You know, the period number tells you how many occupied energy levels or shells you have. So bromine is here, and bromine is period 4. You know, guys, this is period 1, and this is 2, 3, 4. It means it has 4 occupied energy levels or shells. So the answer is 4. So the answer here is 4. Next, name the noble gas which has the same electronic configuration as bromide ion Br negative. Now it's a negative ion, it has gained 1 electron, and just choose the noble gas next to bromine, which is krypton. Okay, so the answer is krypton. Next, aqueous chlorine Cl2 reacts with aqueous potassium iodide Ki. One of the products formed is iodine. So remember, that's a kind of like, we have a reactivity series of halogens, and as I mentioned, the top halogen is the most reactive. It means it can replace whatever comes below it. So now chlorine is more reactive than iodine. It can replace it, and it replaces it in its compound. When you have an ion, it means it's in an aqueous form, and it should have, of course, a positive ion with it, but we are not interested in that positive ion. But now when chlorine turns into ion instead of iodide, it will be a chloride ion Cl negative. Since here you have 2 atoms in the molecule, you should have 2 ions, so the atoms are balanced. And here you have 2 atoms in the molecule of iodine, so you should have here 2 ions of it. Okay, next. Explain why this reaction is defined as a redox reaction. He just needs a definition of a redox reaction in terms of loss and gain of electrons. So just apply which species has lost electrons and which species has gained electrons. So now you know that chlorine, it's an element oxidation number 0, and then it went down to -1. So that's a reduction. So you may say that chlorine, okay, chlorine, since it's a reduction, you know, oil rig, reduction is gain of electron. Chlorine has gained um, an electron. Each chlorine atom has gained an electron. Okay, and on the other side, each iodide ion. Okay, so each iodide ion. So iodide has since it's an oxidation from negative up to 0 in the positive direction, so it has lost an electron or electrons. And if you are talking about plural, so electrons. Or just for a single ion, every single ion has lost its electron, so just I'm talking about a singular here. And of course, it applies for the plural. Next, give the color and the state of iodine at room temperature and pressure. Okay, at room temperature and pressure, you have to memorize the colors of them, and iodide is solid, and it's gray, or you may say black, so it's gray to black, solid. Question 4. Okay, question 4. Um, Here you have carbonyl or carbonyl chloride is manufactured by reacting carbon monoxide with chlorine. Okay, so it's a given reaction with delta H negative 105. Explain what's meant by the term closed system. Even if you don't know, guys, the answer for this definition, or even if you don't know what's meant by closed system, you understand it. So try to express your ideas. So closed system, it means it's like sealed system, nothing can get into or out of it. Okay, just say it in a kind of like in a scientific way. Okay, you may say that there is no particle exchange between the system and surroundings. You may say it like this, by the way. Or you may say, since you are dealing with reactants and products as particles you have in a chemical reaction, you may say that they are not allowed to get out or into the system. So you may say that no reactants or products can enter or leave. Okay, so the most famous definition: no reactants, of course, are allowed to enter, and even products are not allowed to leave. No reactants or products are allowed to um, get out, or you may say to leave. Uh, State what's meant by the symbol delta H. In older versions, we used to call it energy change, but the more scientific fancy term we used to use nowadays is enthalpy. And by the way, they are synonyms, enthalpy. So enthalpy exactly means energy. So enthalpy change or energy change of a reaction. Enthalpy change of a reaction or energy change of a reaction. Show how the value of delta H shows the forward reaction is exothermic. We know that it's exothermic because we have a negative sign, so delta H is negative. So it is negative. Deduce the value of delta H for the reverse reaction, include a sign. Like, tell me, is it a positive or negative? You know that the reaction is written from left to right, it's said to be a forward, the reverse or backward, then you have to simply consider the same value, the same numeric value, but just the opposite sign. So exactly, delta H is going to be positive, 105 kilojoule per mole. Now, what if you forgot to write positive? Unfortunately, I'm not sure if he's going to give you the mark, because he told you that include a sign. In math, we know that if I didn't write a sign beside a number, it's understood to be positive. Like if you wrote 105, it's understood to be positive. However, in chemistry, more specifically in energetics, you have to emphasize that it's positive. You have to put positive, beside it, because he mentioned that include a sign. Okay, next, complete the table. And it's just a kind of like equilibrium game, but instead of telling you like as he used to do before, the position of equilibrium, is it shift to the left or shift to the right, shift or move? By the way, you may use the verb shift or move, they are the same. He just used one of the substances, like what happens to the concentration of that substance. Now you have to check where is this substance located. Now it's located in the product side. Okay, it means if you want the reaction to be, or if you want the equilibrium to shift to the right, now you have more of that substance on the right side. If the equilibrium shifts in the left direction, it means you have more of the reactants and less of the products concentrations. So since the substance he mentioned in the product side, now you have to consider whether the equilibrium is going to shift towards it or away from it. Now, temperature increased. Since the reaction is exothermic, it means you should consider here a presence of heat as one of the products. It's an exothermic, and increasing heat or temperature in that side will push the reaction to the opposite side, I mean to the backward or reverse direction. So the concentration of COCl2 is going to decrease. So the answer is decreases. Now, what if you added some of the CO? Again, you have to check where is CO. CO is one of the reactants, and you're adding more of it. So the reaction will shift to the opposite direction, to the product side. So you're going to have more of the products, and COCl2 is one of the products. So its concentration is going to increases. And he mentioned here just use increases, decreases, no change, but never refer to the shift or position of equilibrium. Now, if the pressure, you have to count how many molecules. In the reactant side, I have 2 molecules. In the product side, I have just 1 molecule. You know that increasing pressure shifts to the direction of the fewer number of molecules. And the product is in the side of fewer number of molecules. That's why its concentration is going again to increase. So increases. What if you added catalyst? Remember, catalyst has absolutely no effect on the position of equilibrium. So the answer is no change. However, if you talked about the rate, then catalyst would affect the rate. It would increase the rate. Okay, next. Now you have an equation, and you have the bonds between, I think Muhammad Tawhid, yeah, I think you had a question here. So I think that's a kind of like a good question to discuss your question you sent me before. Guys, like one of the methodologies to tackle this question is to compare between bonds in the reactant side and product side. Sometimes that's confusing because sometimes you may get confused and you don't count any of the bonds. So I really prefer if you calculate all the bonds in the reactant side, I mean bond breaking, and all the bonds in the product side, I mean bond forming. By the way, the old version, I mean the old strategy, like if the bond is the same, then you don't have to count it. Actually, if you count it in the reactant side and if you count it in the product side, they will cancel each other out eventually. So there is no harm of counting it in the reactant side and in the product side, even if it's not formed or broken, because you are going to cancel exactly as if you are adding like a number on the left side to an equation, and you are putting it on the other side of the equation, so it will cancel out. So you don't have to worry about like counting all the bonds, Muhammad. Okay, now, in the first point, he wants you to calculate the energy needed. Okay, he wants you to calculate the energy needed to break the bonds in the reactants. So now he wants the bond breaking energy in the reactant side. So we have one triple bond between carbon and oxygen. You take its value from the table, and you have one single bond between chlorine and chlorine, and also you take it from the table. So here the bond breaking. Just let me calculate it quickly. So it's 1 times the bond between carbon plus you have another bond, so 1 times the bond between chlorine and chlorine. Take them from the table, so it's going to be 1075. Again, I'm taking the numbers from the table, plus 240. So let me do the math quickly. If you add them, it will be 1315 kilojoules. So the answer is 1315 kilojoules. Okay, guys, listen, I'm doing the calculations very quickly, and sometimes I'm adding numbers using just my mental math. So if I did any mistake, please, you can correct me. Just follow me up. If you found that I'm doing any mistake, just send me like a warning on the chat box. Okay. Okay. Next. Calculate the energy released when the bonds in carbonyl chloride form. Okay, so now he wants the energy released. Okay, the point is I can't calculate that directly from the table because here I have one bond is missing, which is carbon and oxygen. You don't have any information about carbon and oxygen in the table given. So I have to apply the overall equation of any reaction, which is delta H, enthalpy change of any reaction equals the total energy of bond breaking, okay, bond breaking minus the energy or total energy of bond making. Okay, now delta H was given to you as negative 105, so that's negative 105 kilojoules, and bond breaking we just calculated in the previous step is 1315 minus the bond released or the energy released, sorry, by bond making. That's the unknown, that's what he's asking for. Okay, so just let me put here x as the unknown here, and then let me quickly do the math. Now if I move negative x here as positive x and then move negative 105 to the opposite side as positive, so I add 105 to 1315, so now x equals 1420, yeah, 20. So the answer is 1420 kilojoules. Okay, guys, once again, check after me the numbers. If you have a calculator, you can just do it quickly. Thank you, thank you. Oh, thank you, Kenan. Oh, Kenan, you are here, finally. Thank you. Ali, thank you. Okay, okay. And finally, calculate the bond energy for C double bond O. Now, you have everything except that bond energy. So you may just use here the bond or energy of bond breaking, the energy of bond breaking. Sorry, not bond breaking, I'm so sorry, bond making. The energy released that we just calculated in the previous step. Bond making, that's energy released, equals. Now, in the reactant side, when you make bonds, you release energy, and we have two bonds between carbon and chlorine, and you have their values from here, 340, but you have the unknown bond between carbon and oxygen that we need to calculate. So we have two times chlorine, not chlorine, carbon chlorine. Yeah, carbon chlorine. Just a second. Carbon chlorine plus one bond between carbon and oxygen, which is the unknown that we need to calculate. Now, the bond making energy, we got it from the previous step, 1420 equals, and from the table it was 340. Yeah, 340. So 2 times 340. So 2 times 340 and plus one bond between carbon and oxygen. So let's make it X. And then we need to multiply 2 times 340, that's 680, and you take it away from 1420. So if we do the math, it will be X equals 740, yeah, 740 kilojoules per mole. So the answer is 740. I hope no mathematical mistakes. Inshallah, no mistakes. I hope if you figure out that I did any mistake, just guys, let me know. Let me check the chat box. Final, yeah, thank you. Since Muhammad Tawheed approved my answer, it means I'm doing a good job. Thank you, Muhammad, for approving my answer. This is an easy question. Cross and dot diagram, back again. Guys, he just gave you, like, here you have a cross and dot diagram. Yeah, for ionic compound, and again he repeated for a covalent compound. He shouldn't have done this because that makes the exam, like that version of the exam was easy, but you don't know, sometimes it happens in the same exam. We get like two questions on the same idea. I don't know why, but he did it. Okay, so actually here you have carbon. You know that carbon, you have to check how many outer shell electrons. Carbon has, in group 4, it has 4 outer shell electrons. It has to make 4 covalent bonds. And chlorine, one of the halogens, it just needs one more electron to be shared. Let's say that chlorine has a cross and hydrogen and carbon has a dot. So chlorine has 6 other crosses or 3 pairs that are not in bonding, that are said to be free pairs. And once again, here you have carbon dot, chlorine cross. So here you have 3 other pairs of electrons. Now, oxygen and carbon. Now, oxygen is group 6. It needs 2 more electrons, so it has to make 2 more bonds. Guys, the number of electrons that any non-metal needs, it's how many bonds she should make. Once again, I'm going to repeat. Oxygen has 6 valence electrons. It means it needs 2 more electrons. The number of electrons that is needed for any non-metal is how many covalent bond it should make with the other non-metal. So since oxygen needs 2 more electrons, it should make 2 covalent bonds with carbon. Carbon has already dot, so we have 2 dots from this carbon, and oxygen is 2 crosses. And then there are 4 more crosses, 4 more electrons in 2 pairs of oxygen. That's it for the dot and cross diagram. Okay, so here we have 3 marks, such an easy question for 3 marks. Next, how many minutes? Oh, we're approaching, okay, almost we're approaching the end. Okay, so here we have a table, okay, and in that table he's telling you the atomic number. He saved my time to check the periodic table. He gave me directly the atomic numbers of both of these elements. So manganese, it has a mass number of 55 and it has an atomic number of 25. It means it has 25 protons. So it has 25 protons, and if you take away 25 out of 55, that gives you 30. And electrons is a neutral atom, so it has exactly the same number of protons, 25. Now it's an ion, 2 positive. It means it has lost 2 electrons, but it has 20 protons. And to know how many neutrons, you have to take 20, take it away from 42. So it's going to be 22. Guys, follow me. Maybe I make a mathematical check. I'm doing it quickly. And finally, how many electrons? It has 20 protons, 20 electrons. Take away 2. It's going to be 18. Next. Now you have manganese that is making more than one compound with more than one oxidation state. Remember, that's a property of transition elements. They can act as catalysts. They have colors in their solutions, and the reason behind all of this, because they have multiple or variable oxidation states. The question is, so just why manganese expected to form colored oxides? Because remember, that's a property of transition elements, because it's a transition metal or element. A state which other property manganese is shown by forming several oxides. If any element is formed, transition element forms many compounds with different oxidation states because they have variable oxidation. This is a very important property of transition elements. They have many or different or variable oxidation states. Okay, next, state the formula of manganese 2 oxide. The manganese that has a charge of 2 positive, and oxygen, you know that it has 2 negative. Cancel the positive and negative, crisscross, so it's going to be 2, 2. Take the simplest ratio, so it's going to be MnO. Next, any mistakes? All correct. Thank you, Kenan. Thank you. Thank you. Define the term reducing agent. Reducing agent is, agent is like a helper. So it's a substance that helps or reduces another. That's why it's named reducing, but itself oxidized. Okay, so it is a substance that helps in reducing or reduces directly, reduces another substance. Now, until here, I would take just 1 mark. Now, the other half of the definition, you have to tell what happens to that substance itself, and and is itself oxidized. Yeah, thank you. Yeah, reduces another substance and is itself oxidized. Okay, now balancing. Okay, guys, listen to this very carefully. Even if we exceeded the 30 minutes barrier I set to myself, but that's worth it. Sorry, Hashir Sakib. Okay, okay, sorry for that. If I did anything wrong, you can just tell me what's wrong with me. Okay, anyways, so sorry, I will finish, guys. Just give me 5, maximum 10 minutes, but that's worth it, guys. Balancing. Sometimes balancing, guys, is complicated. Listen, if using fractions is allowed, but we don't prefer to use it in the bridge system. But you can use fractions to make the balancing easy, and then you may remove the fractions by multiplying but by any coefficient that will remove that fraction. If you understood anything from what I said, I will doubt that you have something weird with you. Normally you wouldn't understand anything, but let me just apply that to you, or apply that to the question I have in hand. Okay, guys, just try to balance normally, but if you have a kind of like many numbers or coefficients that are not clear, use fractions, and then later on, even if you are using part of an atom, like 3/4 of an atom, or 5/2 of an atom, just use any fraction you want to use firstly to make the equation balanced, and later on multiply the whole equation to give the answer, the final answer. To make my idea clear, guys, let me start by Mn. How many atoms do you have here? You have 3. And there you have how many atoms? You just have 1, so you need to multiply by 3. Just bear with me. I know that later on I'm going to change it, but just bear with me. Okay. Now, let's check here. Before I balance, I need to complete that missing substance here. So I need to read the question. Sorry for that. I just got in rush with the balancing, but let me quickly complete the simple equation by inserting the formula of the missing product and balancing the equation. Okay, so let's try to fill in here the product. Aluminium that's the metal that we have, or the positive should be in the compound. It will take place of the manganese, and then it will kick it out as manganese element. Okay, so we should have a compound between an aluminium and oxygen. Now, aluminium, if you check its position in the periodic table, it should be 3 positive, and oxygen should be 2 negative. Cancel out positive and negative, and crisscross the numbers, so it will be Al2O3. Okay, now let's continue with balancing. So just let me remove here everything, so it will be much easier to follow up. Now I need just to balance. Okay, now I just need to balance. Okay, just a second. Here we go. Okay. Just a second, guys. Okay, here we go. Okay, now we need to balance. Okay, so once again, here you have Mn3, so we need to put here 3, and aluminium, so it's Al, but there you have 2, so you have to put here 2. Now what else? Okay, sorry, let me just, okay. Okay, let me, guys, I'm just going to try to balance oxygen. Let me just try to balance oxygen. Okay. 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 Let me first try to balance the oxygen. Here you have 3 atoms of oxygen, and there you have 4 atoms of oxygen. Okay. Now, can you suggest what should I make in order to make them balanced? I'm just reading the question, guys. Do I have everything good? Okay. Yeah. Hussein. Yeah. I'm just going to give you some tips now, but just bear with me. Thank you. Okay. Let me get back to the question. Here you have aluminium Al2 O3. So if you want to balance oxygen, oxygen here is 4, but there is 3. So I don't have any way to balance them. Except, guys, what if you have in one side 4 and in the other side you have 3 and you want them to be matched? What do you think you should make, guys, in order to make them in both sides 4? Okay, so let me just simplify it. Here you have, let me make it like this. Here you have 3 oxygen atoms, and there you have 4 oxygen atoms. Okay, this is not 30, this is 3 oxygen. Okay, 3 oxygen atoms and 4 oxygen atoms. And I don't have any kind of like an integer, I mean a whole number that I can multiply by 3 and it makes it 4. So what would you suggest? Use a fraction, and in using a fraction, the number that you want to get rid of it, put it as a denominator. So here you put it at 3 down below. It will cancel out with the 3 at the top because you don't need it to be 3, but you need it to be 4. Okay, I'm going to repeat once again, guys. Once again, let me start from the very beginning of it. Let me start with oxygen here. Here you have 3 oxygens, but there you have 4 oxygens. You want them to be matched. You want them to be the same. Okay, so the 3 oxygens, in order to get rid of that 3, so we have 3. Okay, you got 3 oxygen atoms, and here you have 4 oxygen atoms. Sorry. 4 oxygen atoms. I just want to get rid of the 3, so I multiply by 4 over 3. 3 will cancel out with 3, and it will be just 4. So it's 4 over 3. Okay, and now you have the oxygen is balanced with that oxygen. And aluminium, how many aluminium atoms do you have, guys? How many aluminium atoms do you have? You have 2 aluminium atoms over 3, so you should put here 8 over 3. Okay, once again, 4 times 2 is 8 over 3, and here you have everything is balanced. Like you have 3mn, 3mn. You have 8 over 3 Al, and here you have, if you multiply 2 times 4, it will be 8 over 3. But since in bridge system we never accept fractions, now you would find that just one number will remove all of these fractions, which is multiply the whole equation by 2, but sorry, by 3. So if you multiply everything by 3, it will be here 3, and 3 will cancel out at the bottom, 3 will cancel out at the bottom, and 3 times 3, it will be 9. Okay, guys, if it's not clear, I'm going to repeat again. Thank you. So let me just repeat once again for those who didn't understand. Oh my God. For those who didn't understand what I did, let me just start over again. Okay, guys, you can match the numbers using fractions first and then look at the end. Which overall factor, I mean, which overall coefficient I should multiply the whole equation to get rid of these fractions that I have in my equation. So I'm going to just explain it one more time, guys. Sorry for that. Just one more time, and we'll be done, guys. Just one more time. Let me just put here Al2O3. Okay, you have 3mn. I have to put here 3, and you have 3 oxygens, but here I have 4 oxygens. In order to change that 3 oxygen into 4 oxygens, multiply by 4 over 3. 3 will cancel out with 3, and you're left with 4 oxygens. And then you have 2 aluminium in the main formula itself, but it's multiplied by 4 over 3, so 2 times 4 over 3, it will be 8 over 3. And here you have 3 down as a fraction before the formula, and here you have 3. To get rid of them, multiply the whole equation by 3. So that will be 3, and 3 times 8 over 3 will be just 8, so remove the denominator. And here 3 times 4 over 3, it will be just 3, and finally you have 3. Sorry, it will be 9. Sorry, you guys, 9. 3 times 3 is 9. Okay, next. This is a kind of like mole calculations. So here you have mole calculations, and he gave you the volume, and he gave you, what else do we have? We have concentration. Okay, he needs number of moles. N equals C times V. So number of moles equals concentration, which is 0.200 times the volume, but you have to change it into cubic decimeter. So it's 50.0 over 1,000. And then you have to do the math. Okay, so it will be 0.050 times 0.2. So it will be 0.010. You may add if you want three significant figures, no problem. So that's number of moles of HCl. Determine the number of moles of Cl2. Now you have to look how they are connected. Any number is 4 times more than of HCl is 4 times more than the Cl, because it's 4 to 1. So if you have 4, it will be 1. If you have 1, it will be fourth. It will have, if you have any number, it will be that number over 4, or multiplied by 1 over 4. So it will be 0.01 over 4. And I need a calculator. Just a second. I may use. Can you please, guys, do it by calculator to me? I'll try to use a calculator. So it will be 0.2 times 10 power negative 3. Okay, so sorry, I just used my mental math. No, it's a mistake. It's 2.5 times 10 power negative 3. 2.5 times 10 power negative 3. Am I correct, guys? Okay, now the volume of any gas, remember, if you know the number of moles of gas, multiply by 24. So take that number and multiply by 24 to get to know how many. But the trick here, guys, he's asking for cubic centimeters. If you multiply by 24, you'll get it in cubic decimeters. You have also to multiply by 1,000. Okay, so first multiply by 24 and then multiply by 1,000. So I think now I need a calculator. Now it's hard to me to use a mental math. So can any of you tell me, please, anyone, Kenan, Ali, anyone, just multiply 0.5 times 10 power negative 3 times 24 and then times 1,000. Is it the answer 0.0052? No, I think, yeah, that's the answer of the previous point, but I need 60. Okay, Kenan, I trust you. 60. Thank you. Okay, if it's not correct, guys, just check. Just use a calculator. Describe a test for chlorine. Guys, remember, chlorine bleaches damp litmus paper. So the test is damp litmus paper. Litmus paper. So you bring a litmus paper that's damp, I mean wet, and then you put it on the top of the test tube. If it bleaches, I mean if the color is removed, then it's a chlorine. So it bleaches. This is a common question. What happens if you control the temperature? In that situation, I'm going to decrease temperature, so the rate is going to decrease. That's a kind of cliched question. Cliched means it comes like this, and always you have to submit the answer in this order. First, you have to tell me about the energy. Would it decrease or increase? Of course, energy or kinetic energy is going to decrease. That's 1 mark. That's mark 1. And then you have to tell me for the activation energy, EA. So the activation of energy of the particles will be, or less particles will have EA, less particles will have energy greater than or equal to the activation energy. So less particles will possess energy. Particles will have energy that is greater than or equal to the EA. So the number of particles that have enough energy will be decreased. And finally, you have to refer to the frequency of collisions. Frequency of collisions, it will decrease. And finally, you have to tell me that the successful collisions will decrease as well. So all of these factors, they decrease the rate of reaction. Also, you may mention in the first part, when energy decreases, or kinetic energy decreases, they are moving slower. Also, that contributes to the having less frequency of collisions. Now, the last question. In the last question, you have two isomers, two structural isomers, and he's asking you state how they are considered to be structural isomers according to what's given to you in the question. So in the question, they have the same functional group, and also they have the same, since both of them are alkenes, they have the same general formula. Now, if you want to mention differences, they differ from one another by CH2. If you compare here, that B has more CH2 unit in it, and also they are different in physical properties. They have a trend in physical properties. Okay, anyways, just two are enough. Next, explain why A and B both are hydrocarbons. They contain only hydrogen and carbon. Okay. Next, write the symbol equation for the complete combustion of A. A is an alkene. Any hydrocarbon, guys, can make combustion, and always it gives carbon dioxide and water vapor. Count how many carbon atoms you have. You have 3 carbon atoms, C3H6. Any combustion yields carbon dioxide and water vapor, and then you have to balance. Remember, guys, balancing 3 carbons, 1 carbon multiplied by 3, 6 hydrogens, 2 hydrogens multiplied by 3. But sorry, I think I missed something here. I forgot to add oxygen. So any combustion should happen in presence of oxygen. Sorry for that, my bad. So here you have 2 oxygens, and there you have 3 oxygens. Can any of you suggest a way to make the 2 oxygens 3 oxygens? Okay, guys, once again, I have 2 oxygens on the left side, but I have 3 oxygens here in water and 6 oxygens in carbon dioxide. Okay, so 6 oxygens in carbon dioxide. So here you have 6 oxygens, and there you have 3. Overall, you have 9 oxygens, but here I have 2 oxygens. How would I make the 2 as 9? Simply multiply by 9 over 2. The 2 will cancel out with the 2, and finally you are left with 9. Okay. Now, I think there is something I missed. Is anything wrong with that, guys? Sorry, guys, it's not 9. It should be. Sorry, my bad. Yeah. You're correct. Sorry for that, Muhammad. Yeah. So finally, it will be. So it will be 9 oxygens and CH3. It should be here. Yeah, 2. Thank you. And here it should be, when you multiply, okay, it should be 6. Yeah, we multiply by 2, and here it should be 6 as well. Yeah, thank you. Now it's balanced. Okay, guys, if you have any problem with that, just check with me. Just write in the chat box if you have any problem, so I wouldn't repeat if it's not necessary. Yeah, thank you. So 9 oxygens, overall you have 18, and here you have 6 carbons, and 12 hydrogens, and overall you have 18 oxygens, 6 here in water, and 12 there. So overall you have 18. Yeah, perfect. Next, did you use the empirical formula of A? Count all the atoms in A. So you have the molecular formula should be C3, and then you have H6. Divide both by 3, so it will be CH2. That's the simplest formula. Name compound B. Again, once again, we did it before. That's butene, because the double bond in the middle, butene. A structural isomer of B is a member of the same homologous series, and draw the displayed formula. Guys, listen, since this is a recent exam, he used the term display, but in older versions, he used show all atoms and all bonds. So draw displayed formula of the structural isomer of B. Guys, he's not asking for B itself. He's asking for a structural isomer of B. Listen to this, guys. He's not asking for B itself. He's asking for a structural isomer of B. If B is butene, the isomer of it is when it's 1-ene, and he wants a structural formula of it. He doesn't want the name. Okay, you have to be very careful. Okay, so he's not asking for a name. So you have 4 carbons. Remember, always start with carbons and then put everything, put function group and put everything you need to put. So I want it to be 1. So I need this bond to be a double bond at the very beginning of the molecule. And then here you have 2 hydrogens, and here 1 more hydrogen, and the hydrogen there, and 2 more hydrogens. Okay, he doesn't ask for the name, so you don't have to submit the name. Now, this reaction is an addition reaction. In other words, he's asking for a definition. Why is it an addition reaction? Only one product is formed. That's the definition of an addition reaction. And the color change for bromine, it goes from orange or brown into colorless. Name the substance C. Okay, guys, this is an alkane, but it has the halogen twice. So it's di substituted, we call it di, and bromine, if it's a branch, we call it bromo. So it's 2, 3 di bromo. And then you have how many carbons? 1, 2, 3, 4. 4, it means butane. Okay, next. Draw the displayed formula of the carboxylic acid D. Okay, so we need to read the question first. Under certain conditions, 1 mole of B reacts with oxygen to form 2 moles of carboxylic acid D. Okay, so we have B, which is that alkene. It reacts with oxygen and it splits into 2 moles or 2 molecules of carboxylic acids. And he's telling you, and that's not important, guys, by the way, because he's asking you draw the displayed formula of a carboxylic acid that has 2 carbons. So once again, you have the 2 carbons at the carbon backbone and make it a carboxylic acid. It means put the functional group of a carboxylic acid. Okay, that's, you have to show all the bonds. And here you have hydrogen, and there hydrogen, and here hydrogen. I hope no mistake so far. Finally, name a carboxylic acid. 2 carbons means eth, and then ethanoic acid, ethanoic acid. Complete the simple equation for this reaction. So he told you, if you read the question, reacts with oxygen. So oxygen, O2, it exists as a diatomic molecule, and it gives you ethanoic acid. Just try the structure formula of it, which is C2H5. Okay, COOH. That's the formula of it. You need to balance. Okay, so since here he told you even that you have 2 moles, you have to put here 2. I hope there's no mistake in my answer. I hope that. Actually, I didn't get okay. I think that's it. So do you have any questions, guys? Before I go, do you have any questions? Um, in question C, is there a mistake in question C, Muhammad? Question C. Okay, let me get back to question C. Um, can I write CH2 double bond CH3 instead of C3H6? I think it's question 3. Okay, let me get back to question 3. I can't find this in question 3. You mean in which question, Muhammad? Okay, thank you. Thank you. Okay, guys, I think that's it for today. Listen, if you have any problem, if you still have any problem with any of the topics that we didn't discuss so far, like actually I focused with you for topics until topic I think 8 or 7, and then I focused on organic, and then we answered just one complete exam. If you need another exam, we can meet tomorrow. We still have 2 days to the exam, so if you want us to meet tomorrow, no problem. We can meet just for, let's say, an hour, and we can pick any of the exams and answer it fully. If you still have any questions, you can just send it to me on the chat box. I'll get back to the chat box later on, and even if I missed answering any of these questions, I'm going to clarify it more. I'm not sure. I think when this stream is over, the video will be saved on the channel, so you can get back to it. And maybe by mistake, maybe because I was going quickly through it, maybe I did kind of like a mistake. So if any mistakes if any mistakes were discovered, I'm just going to correct it later. But just send me a notification. So see you guys, and I hope all the best for you in the exam. Just relax, do your best, solve as much as you can, and focus on the last exam, especially because many parts have been removed, like carbohydrates and ptyroline, and all of these parts have been removed, and even some terms have been updated. So focus on the last exams and try to solve as much as possible. I wish you all the best, and see you next time. If you need anything, just send a message to me. Thank you. Thank you, guys. Thank you. I really thank you. Thank you. See you.